Look, I think if we learned anything over the last 5 years, it would be not to trust the government. The government is not your friend. Control is all they intend. The playbook stays the same, creating problems to instill blame. Their pre-planned solutions in the macro always slide us toward their game. The tiptoe to totalitarianism. We'd see the truth if not for their designs, crafted by social engineering lines. Propaganda spreads through every speech. Conformity enforces their reach. What we've learned is simple, not hard to see. The government isn't what it claims to be. They wage wars on the populace far and wide, deceiving the world with the truth they hide. History's lessons wouldn't make it clear, but lies keep truth away and still fear. Social engineering, propaganda is might. Conformity keeps us out of the light. The government is at war with its people all over the world. Safety's just a guise for control, and the changes go unfurled like the frog in boiling water. We'll notice when it's too late. We're waking up, but the battle's long and the lies are out for debate. The technocracy is the cause of all the world's problems, funding both sides of every war just for their own sake, subverting resistance in the riots, then using unrest to advance. Plausible deniability is their tool, hiding in ignorance. Stop and think in the end who really wins. Follow the money, you'll find the same faces, the same sins. At the root of every threat, the central bank's in control. As Rockefeller said, it's power, and that's their only goal. If we really knew history, we'd see the truth so clear. But social engineering and propaganda keep us in fear. Policed by social conformity, the people stay in line. Only recently have most of us begun to really open our eyes, to realize the real lies told to everyone. The government is at war with its people all over the world. Safety's just a guise for control, and the changes go unfurled. Trusted your word. Trusted your word. Now I see through, just like all the rest. Trusted your word, believed your Lord. Now I see through, can't trust you no more. Trusted your word, believed your Lord. And now I see through, can't trust you no more. Psychologically abused since I was a kid. Believe in your stories, the things that you did. Now I'm asking for my money back. I have it tallied up, $800,768 fiat dollars. Yeah, gave you my trust, followed your way. Now I see through your deceit on display. NASA, you've been lying to me, lies and deceit.
Firmament is water. So what are you talking about?
I know, man.
Right.
You gotta
No, no, no,
look
no,
at
no, no,
you
no,
gotta
no, no,
look
no.
at some of the papers that
No, no, no,
CM's
no, no, no,
putting
no, no,
out,
no, no, no,
dude.
no. What do
It took
you
me
mean by
like weeks.
outside the firmament?
It took me weeks to get comfortable
Yeah, yeah,
enough to
yeah,
say
yeah,
that
yeah.
CM learned to do
Jabberjaw.
this. Damn, dude. You tell us what
You my guy,
Riemann
man.
geometry is. You tell us what Riemann geometry is. Your own words.
You're asking the wrong person.
All right. I was trying to tell
Danny,
you.
start a room.
It can't be worse than the reframing of the Riley's criteria by Jamal. He basically took the math from Riley's criteria, rebranded it with a new name called angular merging, and then started coming up with his whole, I don't know, mumbo jumbo.
He's not the only one done, so just beware.
That's not
Yeah.
mumbo
Well,
jumbo. That's
No,
just
Dunn is
using.
100% right, bro.
That's just
Look at
using
no, it's
Iron's
angular
mumbo
resolution of
PTR.
the
jumbo. It's
human eye,
definitely
bro.
mumbo jumbo. Okay,
Look
when
at
he say,
Iron's PTR, bro. He's trying to explain Iron's PTR is the ship like disappearing over the horizon as angular merging or like
oh, okay,
angular
oh.
resolution.
Now, when you explain it
That's
like
ridiculous.
that, it makes much more sense. It's a more sophisticated mumbo jumbo. Oh, okay. Thanks, man. I appreciate
It's
that.
Actually,
all mumbo jumbo, dude.
yo,
They're
our
coping hard, dude.
our buddy just quantified that rate, right? The linear progression rate at which things would disappear into the horizon, bottom up on a flat plane. He quantified it into a nice linear progression with a nice colorful Desmos model, giving you a nice output in radians over here. So
I just posted it in the chat stream.
nice. Yeah, I was just like we were just looking at it today. It's so it's like what we've always been arguing is that that's a real thing. It's not that you're misusing Rayleigh's criterion. You're using the angular resolution limit. So if something like an optics or your human eye, it's like tiny was it point oh two degrees or something. So like that's the angular resolution limit, and then at that rate you can say a linear progression. So like the rate the further an object is, it has a linear rate with the distance, the rate
Yeah,
at which
yeah,
So
yeah.
at
are
what point do
seen
you see
Wait,
moving
too
bottom
far?
up.
So at what
wait.
point do you see too far?
Yeah.
You mean how far should the horizon be for an
At
observer on
at
either
at,
model
at
on 6 feet comparatively?
no,
It's
no, no, no.
three
You guys
miles
say
for
no,
both.
no, 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 no. Wait. No. You guys say we can see too far. At what point do you see too far then? If you're saying I can show you bottom up on a flat surface, so at what point do you see too far?
So consequently, it's a 3 miles to the horizon, both geometrically on a globe using
That's not that far at all, my brother.
using the Pythagorean theorem, right? A squared plus b squared equals c squared.
That's
Do the
not that far at all, my brother.
radius of an observer on the height. You end up doing the distance to the horizon is the 1.225 times the square root of the observer's height in feet. That's the geometric consequence of a radius of 3959. Then
Right.
I was just got to
comparatively,
saying, how do we see from Indiana
Wait.
to
comparatively though,
Chicago?
like on a flat plane, you can see just about as far for a 6 foot observer on a flat
Hey,
plane using the
wait.
same
Slow down.
angular
Wait,
rate that we
hold on
just
for a
went over.
second. Slow down. Because you're talking like real fast. You're like, you're talking real fast. Slow down. Let me ask you a question. Let me ask you a simple question. I like to kind of like simplify things because that makes it more interesting versus trying to impress with big words and mathematical terms that a lot of people don't understand, myself included. Do you agree? Let me ask you a question. Do I want to see if I can get you on record with this because I got him on record with it, that Jamal guy, yet he still kept trying to make it about something other than what he was on record saying. So do you agree that Riley's criteria has nothing to do with obstruction? Okay? It has nothing to do with obstruction. Do you agree with that or you disagree with that? That the criterion itself is not based on something obstructing your view. That is, something is in the way, blocking you from seeing either the whole object or part of the object. Do you agree that it's not about that? Yes or no?
No, Rayleigh's criterion is the angular resolution limit. It's the rate at which things would become indistinguishable from each other optically. So
Right,
the
I got that.
way
You don't have to give
the
me the
way
definition. No.
the way
Slow
that
down, slow down,
that's
slow down,
the
slow
way
down. You
that
don't have to give me the definition.
bro, I
I'm
heard
So
you.
that's a
asking
yes.
you, based on that, do you agree that in that definition, it has nothing to do with something obstructing your
That's
view,
a yes.
a physical object? Yes or no?
The way that
That's a yes.
it's used is like say points in the distance. The point say from the front of a building to a back of a building that gets vertically compressed into the horizon, then those 2 points would become indistinguishable, and that's what causes the loss of
Okay,
information from the horizon
Okay,
up. That's the
okay.
relationship
I
of
get, I
Rayleigh's
know what, listen.
criterion to the angular
Listen,
resolution
what you're
limit that we
doing right
said.
now, sir. What you're doing right now, I'm going to tell you exactly what you're doing right now. What you're doing right now is not answering my question. What you're doing right now is giving me you're giving me an explanation of how Rayleigh's criterion is, how it works when you apply the math to the reality we're living in. You're not answering my question. I'm asking you a question, yes or no. Do you agree that Riley's criteria is not based on a physical object obstructing your view of another object? Do you agree, yes or no?
Though
Yes or no?
the context was we gave the distance to the horizon on a physical globe of radius 3959, it came out to 1.225 times the square root of the observer site in feet. You had asked how far until we know it's too far. That was
Do
what
you
started.
agree that
Listen,
Rayleigh
I'm answering your question. I
criteria
let you
is
speak,
not
bro.
about us,
Hey, I let you
one
speak. You're not
object
going to sit here
obscuring
and
your view
dictate
of
what I can
another?
say back to
Done,
you, man.
done. Let's let him finish, done. Because I want to just add something. Just go ahead, done. I mean, shame my
But
fault.
he's not answering me.
Hold on,
Optical,
done,
can you
done.
give me
Let
a
him
yes
just
or
let him
no?
get it out, bro.
The
All
whole
right, let it
context
out.
was the how far is too far. So I brought up the geometric distance of the horizon on a physical globe. It came out with 3 miles. I went through the math real quick. You said it was to confuse everyone. Whatever. The equivalence is the Rayleigh's criterion is using the rate at which two objects become indistinguishable, or in this case, say the points at which the bottom and the top of a building would merge into the horizon, is how Rayleigh's criterion is using the angular resolution limit to actually quantify the rate at which things become the rate at which things disappear into the horizon bottom up. So that's the equivalence for what you think is physical Earth curve blocking the object at that rate, which you approximate with 8 inches per mile squared, which is the parabolic approximation, or you can do the spherical actual. It's the same thing under 100 miles. And this would be the linear equivalent. The thing that Catalan just posted here is a simulator that one of our boys built that quantifies that linear rate.
Okay, okay.
All of that
Real
Look,
was
quick, I
wrong.
just want to say
Optical,
real quick.
optical,
I
real
just want
quick, optical. And you, I just want to
just
say
want to
one
say, do
quick
you
thing,
go?
optical.
I just want to
He,
say, hold on,
he
real
didn't
quick.
answer me, bro. He didn't
I
do it.
got you, bro. Let me just get it out because I barely speak, right? So what I'm saying is done. You done repeated the question. I think the answer is a yes. It has nothing to do with a physical obstruction because it's describing the optics and what we see. You can explain it. Wait, hold on.
Why couldn't he say that?
Hold on,
Why
real
couldn't he
quick.
say
Thank
it,
you,
Okay,
brother?
Brandon.
okay. Right. I understand that. But still, it's just giving you context, right? So regardless, is you can explain it with the physical obstruction. You can explain it just how Shane and Jamal and whoever else has brought this topic to you as far as what we see, what's in Iron's PTR, bro. Real shit, bro. It's like it seems like you don't want to accept the alternative explanation for what we see, right? It's like I'm confused. Like, why do you keep asking the same question over and over and over when we understand that Riley's
I'll
concern
tell
has
you why.
to do with the physical obstruction,
I'll
right?
tell you why.
It's
I'll tell you
explaining.
why.
It's just describing what we see.
Yeah, yeah, I hear you, good brother. And I listen. I'll give you the respect. At least you came on the mic and said, "Yes, it's not about a physical obstruction." At least you were man enough to say that and just say it, and then you went into your explanation, brother. That's number one. He didn't do that. He could have just came on and said, "Yes, you're right, Dunn. It's not about a physical obstruction."
I
Then go
think
into
that was
all.
implied, though.
I don't want to imply it. I want you to answer me straight up. Stop implying. If it is, just say it is. If it isn't, just say it isn't, and then go into your explanation, brother. We got
Great.
all of this
So where are you going
tiptoeing
with
around
this,
the
man?
tulips.
Where
All
are
of
you
this.
going with this?
No, no. All of this
Can
tiptoeing
you
around the
go somewhere
tulips.
with this?
Yeah, yeah. I'm
Can you
going
go
somewhere. I
somewhere?
He
am.
is
I'm
he
going
Where
is
the
somewhere.
fuck are
making
I'm
you
his
going to tell
going?
point.
you exactly where I'm going.
He is making his
I'm,
point.
if you, I'm going to tell you exactly where I'm going. The reason why I'm trying to sharply define the line, okay, where they separate, where they're not the same, because when I listen to you guys tend to blur the lines between the two and make Rayleigh's criterion represent the curvature, meaning that you try to use Rayleigh's criterion as an explanation for the hold up for a second. I was eating a papaya. Pardon me. I don't want to be burping on the mic. Optical, good brother, you are cool dude, but stop it with the thumb down because you know I'm not lying about that. Your boy Jamal was the king of it. Even Ladnell, he tried to do it. He tried. I'll say he did stand firm and say, no, Dunn, it's not about that. But he tried to blur those lines. And that's what some of you guys tend to do. You tend to blur the lines between those two and try to make one synonymous with the other. Like you try to do that and offer that up as an explanation for curvature because Rayleigh's criteria is not talking about curvature. It's talking about how when two objects get so far away from you, they seem to look like one thing. But if you but the light off
Well,
of them, I should say. Excuse me, hold on. I'm
let's just
landing my
ask
plane.
Shane.
I'm landing my plane. I'm landing my plane,
That's
brother.
not what Shane was just
Brother, I'm
saying.
landing my plane and you can go right ahead. Just let me land right here. I was right at landing and you stopped me right when I was about to hit the runway. Riley's criteria is talking about the light coming off of two objects. Simply put, the further it's away from you, it looks like the light is turned into one light. And if you get like a high powered lens that can zoom in or a telescope, you can separate the lights again and see what they actually are as distinguished things. That's what that's about. That has nothing to do with curvature and how bolts tend to bottom up because of the curve. That has nothing to do with that. But yet you guys keep playing around and trying to, blur the lines between the two to use that as a way to get around the curvature. That's the
Okay,
slick
buddy,
shit I'm
you made your
talking
point
about.
4
That's the
times. Can
slick
we move
shit.
on? Can we move on? This
All
was
right.
4 times you made that point, buddy. Can we
Yeah.
move on?
I'm
Yeah.
make it 10 times. You
Well,
sit and
No, no,
everybody
listen.
in
no.
here
It's
makes the
no. It's no
same
reason
point
to,
over
right?
and
So
over
it's
again.
no reason to, done, right? Because it's not a necessary replacement for curvature. You believe that that is curvature, right? It could be, from what we see, but there's an alternative explanation. That's all it is, bro. That's all, right? So
Yeah, so
And it ain't
That's
Larry, and it
not an
ain't Riley's
alternative
criteria.
explanation.
The
so
alternate
the problem
explanation
is
ain't Riley's criteria.
so the problem is this can kind of be simplified a little bit. Even if it's not Rayleigh's criteria specifically, or if it's like some combination of the angle and Rayleigh's criteria, etc. Right? Regardless, would you accept the premise that there could be an optical phenomenon that causes the information loss rather than physical Earth curvature, but it would look the same, because that's actually what our premise is
No.
that it's just an optical phenomenon. Well, you can just say no, but that's fine. But if you don't agree to that, then the conversation really can't progress much further than that, because for us, the optical equivalence there leads to no mutually exclusive prediction just off of optics alone. So we would have to move to other things. Like we could talk about radio propagation, horizontal radio propagation on a sphere versus a plane. We could talk about star collisions by mountains. There's different aspects that would have to be used to reach a mutually exclusive outcome, because if it's just based off of optics alone, then we wouldn't be able to tell. Now, whether or not you agree with the premise or not is an entirely other matter. And if you don't accept that premise, like, that's fine, but that's our working premise, and we, go to move the conversation forward. We look for mutually exclusive outcomes for things like radio propagation, mountain elevations for star occlusions, etc. Things that aren't just optical, like, based solely on the optics alone, because it doesn't lead to a mutually exclusive outcome. Because whatever the mechanism is, it would obviously be identical to what they would say. Oh, look, that's, like, due to geometric Earth curve, rather than an optical conversion of some kind.
Well, there is
You,
a
you- you-
distinctive.
go ahead,
Um,
Hanson. Go ahead.
okay, thanks. So there is a distinctive, at least one distinctive feature to distinguish between the obstruction and Rayleigh's criteria merging. So, I mean, actually, the ions profile is just one such example. So, I mean, there could be the merging, but the thing is, at the same distance, they're there should be no difference between whether the upper, let's say the ship, as in the iron's profile, the upper deck and the lower deck, they should be should be as blurred or as crystal clear, as crisp. So the lower part of the deck of the ship, you can either say obstructed or merged together, but the upper deck is clearly seen. So the structure, they're at the same distance, and so that should be able to distinguish whether it's obstruction or really its criteria is irresolution.
Appreciate you giving a alternate explanation. Both of you guys, Space and Hanson, I appreciate that. That's what I was looking for. I'm not going to say that I necessarily capitulate or agree. I have to do more research, but I appreciate that, because what I've gotten is a rebranding of a pseudo rebranding of Rayleigh's criterion as an explanation for how bolts tend to bottom up, disappear from the bottom up as they hit what we know is the horizon. Those of us who know the Earth to be curved. And I'm saying simply, and I'll stop here, it's just a rebranding of an established phenomena. It's an established phenomena with mathematics that are applicable to the real world. And it was just well, I'll take the math, but I'll come up with new words like angular merging and a bunch of uh, mumbo jumbo explanation to cover the math. But yet the math is applicable to the phenomena that it was applied to and established. Okay, like I don't understand. Like that's what I'm saying. Like, well, what else you got besides using established phenomena as a way to explain your thing?
Well, I think we just disagree on is the what we're seeing has a physical geometric cause from the physical geometric horizon resulting from the physical Earth curve, or is it an optical phenomenon progressing at a linear rate? Because the reason I went over the math is on the surface under 100 miles, using either math formula, it's indistinguishable. So whether it's disappearing at 8 inches per mile squared, or the spherical actual rate, or the linear rate that we're showing you now, it would look indistinguishable. That's the point. And that's why I think that's what Alan was saying, was that's why we usually choose mutually exclusive topics like the cells Theo with star occlusions that have mutually exclusive outcomes instead of ones that are optically indistinguishable. If you only talk about physical or
It wouldn't
optical
look
Earth curves,
optically.
it would look identical. Yeah.
It wouldn't look identical, man. What are you talking about?
Well,
Well, the
for
thing is,
flat
I've already,
earthers,
maybe Shane, I don't think you understand what the mechanism of Rayleigh's criteria. What I said was basically you can distinguish the two, whether it's obstruction or Rayleigh's criteria is irresolution.
Yeah, you guys are misusing Rayleigh's criterion as a dynamic cause of optical phenomenon. It's just a
What do you
facet
mean
of how
dynamic cause?
things
I
actually.
don't think you understand what Rayleigh criteria is.
No, we went over the definition before, and you guys yelled at me
What
for saying
definition?
the
I mean,
definition.
the
It's
Rayleigh
the
criteria
the rate
doesn't
at which
have to.
things actually disappear into, like, when you become indistinguishable from each other. The other guy used an example of two lights merging into one. That's fine. They usually use a Rayleigh disk when two things become indistinguishable from each other. The way that it's applied, though, is not that, look, Rayleigh's criterion explains bottom-up obstruction. It's, hey, here's a angular resolution limit, and that plays a factor in the rate at which things disappear optically into the horizon with distance. Now, we're saying it's a linear rate. You were saying that it was spherical because Earth's a
It has
sphere,
nothing to
and it's
do with
frequently
linear or
approximated
spherical.
with a parabolic approximation. Yes, because the two math formulas would be, on a flat Earth, it would disappear at a linear rate because of optics. On a curved Earth, it would disappear at, say, the parabolic rate, which would be
What is
indistinguishable on the surface, right? If you're on the surface under
wait?
100 miles, then 8 inches per mile squared looks the same as the linear approximation, looks the same as the spherical. That's why you can approximate spherical with the parabolic, because it makes no difference under 100 miles. The same is true for the linear. So there's three mathematical possible explanations for the same observation that are visually indistinct, right? You can't tell.
And it
Parabolic
doesn't even have
rate.
to.
Wait, what is a parabolic rate?
The parabolic approximation, 8 inches per mile squared, right? That's a parabola
What do you mean
formula for the
parabolic?
sphere.
you speak
Write down
extremely
For,
fast.
write down the equation. What is a parabolic rate?
oh my God.
Right in the equation that'll solve the argument. Yeah, Shane.
Wait,
Another
define
way
the
to
terms.
1 second.
Define the
Trying
He
terms.
to look
just
that
defined
What
it.
is
term
a
up right
You just
parabolic
now.
asked him for
rate?
the specific equation.
Yeah.
It's just a
What is a
quadratic
parabolic
equation,
rate?
dude.
Define the
So,
terms.
so listen. Here's what. Here's something you could introduce, Shane. Do you have the math for and the pictures for the object disappearing on the lake when the guy puts his camera lower and there's no mechanism for
No,
curvature?
I'm
It's
asking a term.
not a
What is
long
a
enough distance.
parabolic rate?
Dude, if you don't know what a parabolic rate is, just go to Wikipedia. It's fine.
Well, I mean, you use the term. You should be able to define it.
It's a curve that will eventually curve back in on itself.
It's a
Benson.
parabola. It's a
Like,
parabola. What
like
is a
why are you
parabolic
holding why
rate?
are you holding up the conversation
What is a
on that
parabolic rate?
detail that doesn't have any difference between the linear rate, the curved rate, or the parabolic rate?
Yeah,
Like honing in
what
on
is
this.
a
Hold
parabolic
on a second.
rate?
Hold on a
All of
second.
those are different.
Hold on a second. Holding in on this specific detail, sub 100 miles, as we just talked about, they're all indistinguishable. So
What do
let's
you
just
mean
move
in
on
this
with the
way? You
conversation
should be able to
instead of playing fuck
define the
around.
terms you use before
Yeah,
we get to the
we
conclusion.
define them though, and then you want like an extra special definition and
No,
an
it doesn't have to
equation.
be.
You want the full
You can define your
approximation. Like if you're not
special
familiar with the
definition.
geometry of the globe, maybe you should get familiarized with it before partaking in the conversation.
Yeah, you should. If you want to use your special term, you should be able to define it. It's fine to use special terms.
But that's
Answer,
why you should have just let me
answer real
talk,
quick.
because it doesn't
Answer
matter
real quick.
if it's on the globe, because we could use this on a building, right? If the building's tall enough.
Yeah,
Yeah.
exactly. I mean, it
Answer
doesn't
real
matter if
quick.
it's global or not.
Anson,
It's a
Anson,
mathematical
can
term,
you
right?
repeat what my
It's an
answer was
abstract
when I
mathematical
defined it?
term.
Yo, guy, can you repeat the answer that I gave when you said, oh, define it or whatever. Did you hear what I said? Can you repeat it?
Repeat what?
Exactly, dude. All right.
Yes, I'm
Dude,
asking
you
you a
said some
question. You're not
nonsense of
answering the
closing
question.
in on
Very
itself.
simple.
What are
Wait,
you asking,
On the
Hanson?
parabola,
What is
wait,
going
wait,
on here?
wait.
it reflecting on
I've never
itself,
seen
just
Hanson
like
get
the
activated like this.
hold on. I just looked it
Parabolic
up, and
rate.
it says where it's primarily used, and we got it right here. I just looked it up because this is what we do. We look things up. We're not dismissing the term. We want to
Hey,
know what it
don't give
means.
it to
Go
them, bro.
on, done.
Don't give it
Right
to
here,
them.
right here. Okay, right here.
No,
Enough
no,
of
no.
the.
Don't you don't have to give it to them, bro. The whole
No, no, I'm gonna
conversation
give
is
it.
shit
No,
they don't
bro.
understand.
No, no. We're having a discussion. This stuff needs to come out. He's
It
fucking.
happens
Yes, and they're
anywhere. It
just
doesn't have to
reading their
happen.
script,
Can I read
bro.
it, brother? See him. You like,
No, you
bro?
don't. You don't
Stop
have.
He's
talking
They're
over
proving it
just
me.
happens
reading their
anywhere,
script.
though,
They
So
don't
not
have
what's the
just
no
on
idea
the.
problem
what
all
with
they
y'all
can
talking
Hanson
do,
about.
all
asking
they
for
can do, done is
clarification?
stifle the conversation on a technical
No,
detail,
it's not.
Can
and
I
with
He's
no
read
asking
the
specificity.
clarification.
you
When an
cannot be
answer was
mad at that
given,
man.
and
Wait a
then I
minute, hold on
said,
for a
hey, and
second.
then I said, hey, guy, can you even repeat what I said? And he said,
Because he's
repeat
speaking
what?
a thousand
Guy's
miles
Repeat
per
Bro,
not
he's
what?
hour.
guy's not
repeating
even
Nobody
He
can
listening.
did
Please
say
go
read.
ahead,
repeat
he's
John.
what?
Wait,
closing
wait,
in
wait,
on
wait.
Yes,
it.
Hold on
because
for a
you're
second. Wait,
not
hold on
saying
for a second.
gibberish.
Hold on
I'm
for a
just
Yo,
second.
asking
done.
for
Shut the
the
fuck up,
simple
done.
definition.
God damn it, bro.
See him?
Wait, wait. Hold on. You upset with that guy for asking you to qualify a term? Like, well, what's
I
wrong with
did
that?
We
qualify it.
did.
I
We
did qualify it
immediately,
though, and then
yeah.
he continually said no, and then asked for
That's some
equations,
nonsense
etc.
of it closing in on itself, and
Hey
I
Hanson,
have
hey
no
Hanson,
idea.
It's an
hey
arc
Hanson.
that
Were
will
you
eventually
satisfied with his
close in on
answer?
itself.
Yeah. What's your question again?
Satisfied with his answer, Hanson?
Say it again.
Were you satisfied with his answer when he claimed he qualified the term? Were you satisfied with the answer?
No, he's uttering
Well, I'm
gibberish.
interested in what you
If you
looked
plot
up,
out a
Don.
parabola, okay, real quick. If you plot out a parabola, does it spiral in on itself? Yes or no?
What do you
That's
No,
mean
it.
spiraling on
no.
How
itself?
about
All
I
right.
just read? How about I just read? Can we
If
just
you
do that?
what? If you
What
what
is
a
it?
Where is it
parabola?
It's
I
primarily
missed the
Done. We
used?
question.
believe that you're
Spiraling on
capable of using
itself.
Google, bro. It's fine.
Where is it primary? Okay,
okay. Okay.
I'm
Okay.
sorry that I'm just not. I'm sorry that I'm not walking around with parabolic rate in the front of my fucking mind, my man. I apologize. I'll do that for you. Okay, just for you, especially. I'll fucking remember to keep parabolic rate in the front of my
All
fucking
right, Dunn.
mind.
How about you just copy and
It's not
paste it
about.
in the
We're not
chat, please,
Dude,
so
asking
we
you
can
if
get
you
the
know
I
what
the
it
you
is.
do.
conversation going. Dunn,
I
just paste it in the chat,
described
please.
it.
I
I
Thank you.
am. I'm
said
on a fucking tablet reading it, my man.
Oh
It's a
Copy and
fucking
wow.
paste it in the
I
chat.
definition.
said I said
It's a
One
parabolic
definition.
rate.
one
What the
time I
hell,
said the
dude?
wrong equation for the parabola in Pro's room, and he still drags me for it, and life goes
Why y'all
on. Just
stopping
Okay,
move
him from
on.
enough of
reading it?
this.
The
Let me just
whole
give you a
time
quick
y'all been talking,
definition.
he could have
For
read it by
anybody
now.
who's really interested in the definition, parabolic change. We're talking about distance from you to the target and how that changes with vertical. You looking at it, vertical being straight up. How does y, change with x? This is the
Parabolic
rate.
rate. He didn't
Yes,
say parabolic
parabolic.
change.
Shut your ass.
He said
Anyways,
parabolic rate.
shut
You're
your
changing the fucking
ass.
term, nigga.
Done,
I'm
done.
I'm
Done. Just
halfway in
have
the
some
middle of
patience,
something.
bro.
Why are you interrupting me?
We got guests, bro. Just
Y'all
come on, bro.
interrupted him
Okay.
first.
The question is, how does y change with x? Okay. When he says 8 inches per mile squared, he means 8 inches of y per x mile distance, and that distance squared. 8 inches per squared mile. That produces a parabola when you look at it in the cross section. Distance and how your vertical changes with distance. If your distance is a value and you square it to produce the vertical change, that produces a parabola in terms of its shape. And what these guys are trying to tell you is that when you plot that shape from the top of the object, that for the first 100 miles, there is no perceivable nor measurable distance between the drop in y using the other formula or the third formula. The point is that they are all the same, give or take 1% under 100 miles worth of the x value that we're talking here. Is that clear for everybody?
Oh my God! Thank you,
Well, that's a
Stone.
lot of word for to saying y is equal to k x squared.
Yeah, but they weren't going to be happy with that, and you know it. Okay,
That
so I
is
had to break it down for the
yeah.
preschool,
Well,
so everybody's all caught
I'm
up now.
asking
Okay,
Wait. I'm
for
just trying to
just
clear
given a
something up
simple
because he
answer,
said
right?
parabolic rate. Now you're saying
Yeah.
parabolic change. I'm just
it's an
trying to get clear.
exponential rate. And it's because you are squaring the miles away from you, the x value, it has an exponent of 2. That produces a parabolic curve with the value y with the increase in x. That is how you produce a parabola. Now,
Right.
the point here is that curvature, as you move from origin at the top of the object, is indistinguishable from the curvature produced from the circular formula using a radius or from the other linear, you know what I mean? They've got 3 formulae that when x is less than 100 miles, that the y value that comes out of each of those 3 formulae is the same fucking value, give or take 1%, meaning they are substantially equivalent.
Oh, you
Okay,
said
it's that simple.
less than 100 miles, right? Less than 100 miles, you said?
100 miles, anything
Yes.
from 0 to 100 miles.
It's way less than
That's the
100
kind
miles.
of margin you're expecting.
But one
between
guy
them.
said
So
parabolic
Real
rate,
quick.
and this guy is saying parabolic change. I'm trying to get them to be clear first with me.
Yeah,
Which one is
okay.
it? What's the
You
term?
do
It's
No,
understand
no,
what
no,
I'm
don't
saying. You
fucking
symmetrical.
do understand
don't
It
what
should
I'm
be
speak
saying, right?
arrogantly
exponential
to me.
instead of parabolic. They were describing the rate, and it resembles something parabolic. I don't think you should be talking about this
You
anymore
should
No,
at
I
not.
all.
need you to define the term. Is it rate or
I
change?
just
Rate and
fucking
change are
did.
Rate
two
and
different
change are the
things, my
same.
man.
Oh my God. How unbelievably pedestrian of you to even ask the question. You should feel
Pedestrian.
embarrassed.
That's crazy.
Pedestrian because you don't understand. Okay,
Yeah.
so
I
the
should feel embarrassed for asking
I'd like to
questions
make
to
a
gain
correction, please,
understanding.
if you
That's
don't
what I
mind.
should feel embarrassed
Yeah,
about. You
you should
sound
come to the
fucking
table
stupid.
with
You
requisite
sound
knowledge.
fucking stupid. You sound
You
fucking
should
stupid.
shut up. You
Hey,
should come to the table with
hey,
requisite knowledge. It's that simple.
so
yo,
those 3
Hey, don't bring him back
equations.
up.
It's not about it has nothing to do with Rayleigh's criteria. All right. So the
Oh my
3
God, dude.
equations, I know what you're talking about. The one is the parabolic, and then the other, the parabolic
Spherical r
y is
minus r
equal to
times the
x
cosine of
squared,
theta.
and the other is a trigonometric function. Okay, and then the others you can linearize it and whatever you want. But that has nothing to do with the Rayleigh's criteria. Obviously, you don't understand what Rayleigh's criterion is.
I didn't mention it at all. I wasn't even talking about
Yeah,
Rayleigh's
I'm asking
criterion,
Shane.
and I
It's part of
wasn't
the
comparing it
conversation
Yeah,
either.
that's going
well,
Yeah, I
on.
keep trying to separate
Shane
it
was
from
talking about
his
the
explanation.
parabolic rate, and actually, it's not parabolic rate.
really
Okay,
quick
the
though,
rate is linear,
What are you
I just
talking
Oh,
want to,
this
about?
is
and it's
The
so
function is
sphere
also
has a
fucking.
parabolic.
parabolic
I just want
rate
to
What
make
an
a small
absolute
insertion.
bore you
approximated
are,
by
Hanson.
8 inches
Shut
per
up.
mile
I just want to,
squared,
Shut
I just
dude.
want to
up.
make a
Do
small
you
insertion.
disagree or do you
You
not
don't
know your own
understand. You're
model already?
moron.
If you would look in the side chat, I put a link in there, and if you just click on it, it'll pop up a very convenient 2-minute video. Will show you how bottom-up obstruction happens for objects that are nowhere near the geometric horizon, and it's perfectly explainable through what we witness in the
They don't
atmosphere.
understand any of those words.
Just the
I'm sorry,
atmospheric
dude.
effects that happen when
That's too
air
many.
mixes. People literally took bread clips,
Wait,
a
now
phone
it's
camera
because
on a
of the
table.
atmosphere?
Yeah, have you ever looked out at
What did
like
you say?
Skunk Bay, for example, and you see the horizon move throughout the day on a stationary camera? Never seen those
No, I have no
videos?
idea what you're talking about.
You've never seen the videos where they just
What happened?
look up Skunk Bay, or just click the video I have in the side chat, which would be easier. I'll paste the link again.
So is it like a
No, wait, bro.
time
Okay,
lapse?
look at coffee. Hold on. Look at coffee Myers PTR. You're gonna say that bottom up obstruction is
But
because of the atmosphere now.
but
So
until
you
you
guys are
look,
moving away from Raleigh's criteria because that's
listen,
wrong. And now
listen,
you're gonna say
listen.
it's because of
I
the
just
atmosphere,
joined the
which is also wrong.
conversation. I just joined the conversation. Listen to me. I am telling you that bottom up obstruction is not caused by curvature.
Okay.
That's what I'm telling
Well,
you.
and I'm telling you, you're wrong, bro.
Okay, so
It's
look at the
definitely not
video in
atmosphere.
the side
The
chat.
surface of the water
This
causes
video produced by
causes
some flat
causes
Earth
the
idiot. Fucking wrong, bro.
No, it is an experiment with a table and a camera and
Yes,
little tiny objects.
I've seen that. The camera is slightly below the table. This
No,
is
it's
why
not. You haven't seen. You
when
don't
he
even know what the
slides
video
it,
is.
yes,
No, it's not.
I
we
hang
went
out in
over
this
this
room more
angular
than
merging
you,
like a
bro.
hundred
I've seen
times,
every
Hold on,
CM.
bro.
video.
Just real
I've seen
quick, CM.
every fucking video.
CM, you need to calm down, bro. Like Pete, just he said he just got on stage, bro. Calm down. Let him just,
I know. I'm telling you,
right. But
he's
he's
acting like I haven't
describing a
seen that
video.
video of them like sliding
No,
a little object
on
He
a table.
describing the
Yes,
No,
video
yes,
that
that's not
happened.
what
yes,
they're
yes.
doing.
Linnell's
No, you're not even
prove
describing
that it's
anything
the
to do with the video.
surface.
You're not
He's
describing anything in the video. You don't even know the video. You haven't seen it. I know you don't know because you're not describing it correctly. You're talking about something different. So
he's
how
talking
about you
about a
calm
video
down?
that Linnell's proved that the surface can cause this merging, and instead of there is no curvature, and we're still getting that merging effect on the and CM saying he's seen that video, and what is the next logical step after that, CM? What
Look,
is the next fucking logical step?
I
How
wish
could you even
my
argue
point wasn't
this?
getting hijacked by other people right now.
That atmosphere causes it is
Bullshit,
ridiculous, bro.
bullshit.
CM,
Just
There,
shut
see,
up,
there's no
Alien.
logical step there. See, I knew it.
so
Show me
I'm
where
going to go
in
ahead and tell
Iron's
you.
PTR is the
I,
atmosphere causing
I'm
it.
go- I, I'm
It's dipping below.
I'm going to go ahead and tell you what
Stop muting
happens
me.
in the
It's
video that I
dipping
shared.
below the water.
Chill, bro.
How is that
Chill,
the
man.
atmosphere?
Like, just chill. Let the main man get it all. Let him get his argument off.
Yeah, so
It's
if
already
you
wrong.
yeah, it's
Yeah,
already
but you
wrong
didn't
to
have
even
any
have that
logical
per.
next steps. CM, let him talk.
Hold
It's
on.
so
Just let him get
interesting.
it off, man. Come on, y'all.
People are wrong, even though the other people haven't even spoken yet. It's hard to be wrong when you haven't spoken. That's actually crazy, but I'll go
You
ahead
said
and
it's
just finish. So in this video, they take a table, they put a camera on it where the camera sensor is just barely above the camera surface. Obviously, the table's flat. They take a bread tie clip and a couple other little tiny objects that are about the same size. They're like a centimeter thick or so. They show you the measurements. And then they put the camera on them. They zoom in to where it's simulating looking out at an object on the ocean. Then what they do is they open the door and allow the air in the room to mix with the outside air, which are two different temperatures. And when they do that, you see in the video as the air mixes, the objects begin to obstruct from the bottom up. They begin to vanish from the bottom, just like you see ships vanishing on the horizon. And then once they close the door and allow the air to stabilize and to go from turbulent to laminar, then the obstruction goes away and you can completely see the full objects again. It's a perfect demonstration of bottom-up obstruction, and it's caused by turbulence in the atmosphere, by atmospheric gradients between temperature and pressure in the air.
Are you done?
Yeah.
That is so ridiculous, bro.
Then watch it.
No, I'm
I'll
not
just watch it.
downloading anything.
Really,
I
right
already
there. So
clicked the link. It's telling me to
so
download some
someone is
bullshit.
providing you proof, and you're saying
It's not
that's
proof
stupid. I
of
don't want to
shit.
see the proof.
It's
I
not
don't want to
proof of
see it.
jack
I'm just going to
shit, bro.
say that you're wrong without engaging with the evidence. Then you might as well leave because that is
It's
the
not
behavior of
proof
someone who
of
doesn't have the
jack
mental acuity to
shit,
be able
bro.
to participate in the conversation.
Yeah. You're gonna. They gotta keep muting me. That's the only way you're getting away with it.
Someone shows you a video. Someone says that your wife's cheating on you, and you're like, "No, that's stupid." They show you the video and put it in front of your face,
I don't
and
want
you
to look at
cover up
that,
your eyes
dude.
with a
Yeah, I'm
blindfold
not
and say, "I'm
looking.
not looking at that. That's stupid. I don't believe it."
Great example,
Would that
bro.
make me stupid
You're a
or you
fucking
stupid?
idiot.
Who would that make stupid? Would it be me or you that would be dumb in that situation?
Yeah, absolutely one-to-one example. Like,
Would that
wow.
make me dumb or you dumb?
Yeah, I mean
Forget it, bro. They don't want me to talk. They're muted.
it's a cool video. We don't know if it matches the conditions every time we see a bottom up obstruction.
Hold up, coffee.
Well, I guess you'll have to find more videos like that. I forgot the young lady. She's a flat earther. She was in the room. She actually explained the same thing earlier, but it was a different scenario. She was talking about if you're in a hallway versus you standing up and
Oh
if
gosh,
you like lay down on the
Sounds
ground.
like Taylor.
who did it?
Yeah,
Others.
you can
Oh,
also without
She's
invoking the
not on the stage.
atmosphere. You can also do it without invoking the atmosphere, just from the way that objects disappear as you move further away towards the convergence point, and the angular resolution of your eye as a ratio of the distance away. Objects from the ground have to converge at a faster rate than objects from above because they both have to meet in the center. So there's this ratio of ground to center line and sky to center line. Since the ratio of sky to center line is much broader, it doesn't compress as much. But that's why you can watch someone walk away across a warehouse floor or across a flat field. And if you put the camera right above the ground, they will disappear up to like their knees by the time they get to the other side of the field. Like their whole lower parts of their legs will be gone, will not be visible in frame. And you're not going to obviously argue that the warehouse is not flat or the field is not flat. If that person's thigh is 2 feet high, you're not going to say that they dropped 2 feet walking across that field or that warehouse floor.
Except none of that happens.
So at what point do you see too far? If you guys are saying down the hallway, closer to the surface, on a flat surface, people are
3
disappearing
miles.
from bottom up. So at what point on a flat surface you can see too far? Because that's you guys' claim as well.
So that's a really interesting question. But there's an atmospheric effect called contrast reduction. So I'm sure you're
In
familiar
a hallway? In a
with
hallway?
refraction. What's that?
In
No,
a
just in a,
hallway?
no, just in a hallway. It would be just the optical convergence from the ceiling to the floor. So like you
But the
could,
point is,
if you go closer to the ground, right, things are going to converge. You're not going to see as far down the hallway. And if you raise an altitude and go closer to the ceiling, it'll be the opposite. So sorry, I thought you were talking about how
Right.
far you
Like
could
that's the
see, just
difference
like in
between
general, like across the ocean or something. My
no,
bad.
but
It's the
that's
same
you
reason.
under
It's the
the
same
tree
reason
versus
train
above
tracks
the tree.
appear to not be to not. Train tracks appear to converge, even though they don't converge. Lights in a hallway appear to move lower as they get away from you, even though they're not.
Yeah, dude, that's called perspective. We know perspective.
Correct. Yeah. So that convergence, that optical convergence, is the same thing that causes people's legs to disappear when they walk across a warehouse floor. If you put the
But
wait,
if
camera on
you
the
wait,
floor.
zoom
wait,
in, you'll be able
but
to see the
but
legs again, right?
wait,
First of all, I don't even think the
but
legs actually disappear the way you're saying. But
right,
even
but
if
you
they
guys,
merge a little bit, you can just zoom in and bring them right back, right?
That's true
Up to a
to an
certain
extent,
point.
but even within
Yeah.
zooming though, there's still a resolution. There's a new resolution limit that has to
Yeah.
be
It just
that has
changes
to
the
be
Then
reached.
resolution
right.
then you
You
limit.
won't be
zoom
able to
in,
see it.
you're
You know.
widening the resolution limit. That's what
So
zooming
that's
in
what I'm
Yeah,
It's
means.
when
actually
asking.
you
based on
zoom
pixel
in,
count. So there's a function like your eyes can own the sensor. Your eyes are a sensor basically, just like a camera sensor, and your
Okay,
eyes can
okay,
only
okay, so
resolve a certain number of pixels, right, based on the
okay,
sensor size.
okay,
So that's why you get
okay.
a
Yeah,
bigger sensor with a
and the
bigger
object
camera
is
lens, and you can see
disappearing
So
more.
way before that.
Yeah, you're
right,
changing the
that's
aperture,
a
guys.
different subject. Yeah.
It's the aperture.
but
Whatever,
when
I
you
gotta
can see
go.
too,
Dumb bitch rambling is not gonna let me.
but when you can see too far, when you can see too far, where's the observer then if he's not on the surface, closer to the surface of the flat Earth? Where's the observer when he can see too far on the flat Earth? Where is he?
What do you mean? Where is he? He's standing wherever he is.
When you
I don't understand your
when you
question.
guys say we can see too far,
Yeah.
that's why the Earth isn't a globe. Where's the observer?
What do you mean? There's not a singular answer to that question. Every observation would have their own
Where
observer. I don't understand.
where is the observer when you guys say you can see too far? Because you're saying if you get closer to the surface, objects disappear from bottom up. So where's the observer on a flat Earth if when he is
Are you
seeing too
looking for a
far?
particular answer? Like, go ahead and give me the answer you're
Yes,
looking for.
yes, I
He
am.
thinks
Are you
that there's a
listening to my
curvature
question?
involved.
Go
Gator,
ahead and give
I'm
me the
at
answer you think that
no,
you're looking for. I don't understand your
no.
question, bro.
Oh, hear
Okay.
what he said. See too far. Somebody in the room stated you when you see too far. He's asking, what do you mean by that? How can you see too
You're
far?
seeing
The only
further
way
than the
you,
geometric horizon should be based on 8 inches per
yeah,
mile
At
square.
any
and he wants to say
altitude,
curvature. Yeah.
Gator,
at
Gator, no, no,
any
Dude,
no, no.
we
Gator,
altitude,
no.
Lion,
Gator, no.
that's the answer. Lion, your answer to
we
your question is
we
at
quantified it
any
immediately.
altitude, we see too far.
Yeah, okay.
The
Yeah, no,
surface then
I
on
think
a
he's
flat.
trying to make a
Yeah.
comparison
Yes.
of.
Yes.
Hold on, Gator, hold on. I think he's trying to make a comparison of how you guys say that this bottom up obstruction occurs close to the surface, and somehow at the surface you still see too far. So how do you compensate for
I
the
think
two?
you're okay. I think you were conflating two different things. So what I was saying
You guys are
is
conflating
when you
two
put
different
the
things.
camera really close to the ground, the bottom up obstruction happens sooner because the closer
Okay,
you are
so
to the
at what
ground, the
point
more
can you see
drastic the
too
optical
far?
convergence from the ground to the
Okay.
midpoint becomes. As you raise further up above the ground, there's a greater distance between the ground and the midpoint. So the optical convergence is not as extreme. Just like the sky to the ground
So
is
how
not
can
extreme at all because there's a huge
so
distance
how
from the
can you
sky to the
tell
ground.
so how can you tell on a flat surface that the earth is flat if you can't see it
What do you mean?
closer to the
We do it by nullifying the antithesis, right? By the absurdity of the alternative.
Null hypothesis, bro.
It's either flat or not flat, right? So
right,
if
but you
we
can't see it.
nullify, if we falsify that it's not
You
flat,
can't see it at the surface. You're seeing something obstructed closer to the flat surface. You're saying objects are obstructed. How is that flat to you? How is that flat to you?
If I can see objects beyond where the horizon would be blocking them, then it must be the actual horizon must not be there. It must be further.
Well, why doesn't it look like the hallway in my PTR? Why can I see the bottom of the boat then?
You can't up until a certain point. We already said, depending on what sensor you use, like your eyeball, you can watch it vanish bottom up with your eyeball. You pull out your camera, you can see it
So
vanish
where?
bottom up with your camera,
So
zoom in, then it does it
okay,
again, and then it does it again until you run out of zoom.
right,
Well,
right.
depending
So
on where you are, things change, right? The shape, the perspective.
You do realize if it was based on curvature, zooming would never make anything appear that wasn't there before, right? Like
I
that would
didn't
never
say
help
anything
you.
about curvature. I
But I'm
didn't say
saying
anything about
the
curvature.
perspective changes depending on where you are.
But
Just
like,
like
you
if
know,
you're
if
on an
something was
airplane,
behind
as
the
you go higher
horizon,
up.
you'd never be able to zoom in on it and bring it back into view if it was behind the horizon.
No, but so that's why I asked, on a flat surface, how can when at what point can you see too far on your standing on your flat
Too far
surface?
compared to what?
No, standing on your flat surface. Forget everything else.
What is
You guys
defined
say
by too? What do you mean by
He's
too far?
literally
you
quoting
Too
say
far.
somebody
you
What
that
does
you
that
say
mean? What
you
somebody
is
say
too
you
said
far?
that
can
in his
see too
room.
far. You say you
Too
can see
far.
too far
What
on
does
your
that
flat
mean?
on your flat. You say you can see too far on your flat surface.
Too
You
far
guys
for
show us
Quoting
objects.
something that was
You
said, so
guys
you have
show
to
us
ask
you
the
guys
person
show
who
us
originally said that.
objects at 20 miles, 40 miles. You guys
Yes.
use lower wind further than 3 miles, and I've heard the horizon on the flat surface begins to obstruct at 3 miles. That's not far at all. So I'm asking, at what point on a flat surface do you see too far? Because three
It
miles
depends
is
on
not
how
far,
far above
bro.
the surface you are, bro. There's
The
a
answer,
mathematical equation. Like
Lion,
it,
the answer
if
to
you're
your question, Lion, is all altitudes.
yeah,
We
like if
see
you're
too
6 feet
far.
tall and if your eyeballs are at 6 feet, let's say you say you're like 6'3" or something, 6'2", your eyeballs are at 6 feet. If your eyeballs are at 6 feet and you look out straight, horizontal, then you should see the horizon at 3 miles away. You should not
It's
be able to
not
see
far.
anything past three
That's
miles.
not far. It's not
Well,
far.
that's the math. That's literally the Pythagorean theorem applied to a
Okay,
sphere of
that's
35
Well,
fine.
mile
didn't
That's
somebody
radius.
fine.
make the math earlier about
That's
100
fine.
miles? Because we talked about earlier that we can see, I can literally see
So
from
yeah, I mean, if you
Chicago
want
to
to
Indiana.
disagree with the geometry here, you can get proven wrong with math. That'll be really easy to do.
I
But
can see from Chicago to Indiana,
Disagreeing
which is
with the
clearly more
math.
than
We're
3 miles.
disagreeing with your reason why we see what we're seeing. Your explanation is trash.
yeah, so when we shoot laser beams 35 miles out, 2 feet above the ground, and see them on the other side, you think that that's trash?
Wait, but so then why are you telling me at 3 miles that that laser beam is not obstructed?
What
You
I
now?
just
didn't say
crushed
that,
your
bro. You're
whole.
So,
literally strawmanning me right now. How about you actually listen to what
Sure
I'm
am.
claiming
I
and stop
sure
putting
am.
fake
Yep,
claims in
I
my head
sure am.
or my mouth? Listen,
but you went from
I
horizontal
said
to
on a
vertical.
sphere. Now, I'm not claiming we live on a sphere. On a sphere, it is necessary, if the sphere is the size they say that Earth is, it is a requirement that if you're 6 feet high and you look out, the horizon will be 3 miles from you. That is a requirement. That is the tangent line
Well,
that you
but
trace to the horizon. It's a math.
okay, so for a flat Earth, it should be different, right?
Yes, which is why we see past that. We don't stop seeing at 3
Okay.
miles.
Okay. Well, your
That is
brother earlier
verifiable.
said,
Nobody
"Okay."
says you stop seeing at 3 miles.
Wow.
Long time to get there.
Yeah, really hard to progress conversations.
John, the Globe math, like he said at the first of his point, the Globe math demands that you are not able to see any farther than 3 miles
That's
at that
ridiculous.
interval
That's ridiculous, bro.
due
Come on.
to
That makes perfect
curvature.
sense. That makes perfect sense. Yeah, I don't know what
Due
you don't
to
understand.
The
rate of
geometric horizon is
curvature.
3 miles for a 6 foot observer. Doesn't mean that's how far you can see. You can,
So how do you see an object hidden behind a hill?
for
If we're
example,
out in the
if
field and
you're
there's a
six
hill in the
feet
middle of the
tall,
field and I run behind the hill, can you see me?
listen, bro. If you're 6 feet tall and your geometric horizon is 3 miles, then by symmetry, you go another 3 miles. You can see any object that's also 6 feet tall. You
Yep,
understand that, right? You've already
that's
doubled the
trivial.
distance you can see just for any object 6 feet tall.
Yes,
That's not
and the
taking into
calculator.
account.
Okay, gotcha.
That's
So
not
the
taking into account any
calculator.
refraction, anything else. This is just pure
Yeah, I
geometry.
mean, how stupid do you have to be to think that the horizon at 3 miles means you
All
can't
of a
see
sudden,
further
at
than
So
3
3
miles,
so
miles?
hey CM,
absolutely nothing.
you know that the calculator incorporates the height of the other object too.
No, to calculate
Yes.
three
If you're
miles
saying
for a
3
6 foot
miles.
observer, bro. I have the thing in my PTR. What I just described. Hold on. I've actually done the calculations, bro. You guys just plug it into like an online calculator. If you want refresh my thing, this is what I'm talking about. Just for a 6 foot observer, and this is just pure geometry. This is not taking into account any refractive effects, any the temperature, anything. Just pure geometry, which is not where we live. Saying that so what Corey said that at 3 miles you automatically don't see anything is ridiculous.
So
Crazy.
if you use this calculator, I just put it in the side chat, it will tell you the target hidden height. Okay. So what you do is you put your eye height and then you put a distance, and it'll tell you how much of the target is hidden. So that's what you're talking about. How, like, at 3 miles, that's where I clip the horizon. So if I go beyond 3 miles, I go to 3.5 miles, for example, 0.167 feet. So in order to see something at 3.5 miles, it would have to be 0.167 feet. So if I go to 6 miles, for example, I would have to, the object would have to be 6 feet, just like you
Like
said.
I just said, I
Now,
know the calculations in my PTR, bro.
yeah, so the bottom of the boat, how high above the water is that?
Right. So the bottom of the boat is what we're not
Dun dun
seeing, but we still
dun.
see the boat, right?
Weird. The bottom of the
Partially
boat should
or
start disappearing
completely?
beyond 3 miles.
Yeah, it kind of does. By
It
and
does.
you can see the top of a boat around 6 miles. It's like
Oh, so if I show you the
5.87.
entire boat at 15 miles, what are you going to say?
That's because again, this is pure math. This is not where we don't
At
live
15
in
miles,
y
it's
equals
96
x.
feet, bro. Hey, at 15 miles, it's 96 feet.
Dude, I know the curvature. It's not even a curvature formula. This is vertical drop formula. I know I've heard it a
This is the
million times in the
Pythagorean
street.
theorem applied to a sphere.
Vertical
I am
drop.
aware,
Wait a
bro.
minute. Are you saying that water slants?
What are you talking about, alligator?
How's there a vertical drop
On water.
on water?
Look
Yeah,
at my
how's there a
PTR,
vertical
dude.
drop on water, CM?
Look at my PTR. The vertical drop in here is the 24
Hey,
feet.
hey, at 15 miles, there'd be a target hidden height of 96 feet, bro.
He
So
doesn't understand that. He doesn't understand that.
when I show you the boat at 15 miles and you can see the boat, it doesn't matter if the bottom part of the boat's obstructed or not. You were like, oh, look, that's curvature. If it was curvature, you wouldn't see the boat at all.
What's the
Okay, do
difference
you understand what
what's the
refraction is?
difference in where the observer is where you're
According to who?
claiming in this 15 miles? Now you're claiming further than 3 miles. So what's the difference?
I
Where's
never
the
claimed that we can only see 3 miles, bro. Are you dense?
okay?
That's
So when I ask you the
exactly what you
question,
Nobody
claimed.
Yeah,
said
for
that.
so
real. Corey said that. You're like, yeah, dude.
Hey, one of these guys was
so
comfortable enough to say 100 miles, if I wasn't mistaken.
when I
That was
ask
the
you the
math somebody
question,
presented.
when I ask you the question,
Yes, you're
how
mistaken.
far is too far on a flat Earth? Can you see? You said
On
15.
a
Is that
flat, dude, on an FE, the limit to your vision is determined by atmospheric opacity, and it's not an easy solution. It depends on the day.
And it's why the horizon
okay?
can't
Okay,
be sharp on a
but
flat
you
Earth.
just said you could see a boat at 15 miles. Can
Yeah,
you see
John.
Yes,
Where's
further than
yes, you can.
where's your
Yes.
PTR, John? I know you
Can
got
you
Like,
it.
see
bro,
further
do
than
you
15
understand? Like, you're
miles?
not understanding the argument being made to you right now. Do you understand that? Like, you're
Yes.
horribly misrepresenting the argument being made to you.
No, you
But you're
just gave an
confusing.
observation at 15 miles, and I'm asking you, can you see
Yeah.
further than 15 miles?
Yeah, because in the observations, like, for example, the ones with the boats and the buoys and the oil rigs, the Black Swans, for example, those oil
Okay.
rigs are at like 12 and 18 miles and numbers
Okay.
like that. And you can see boats
So
in
my
between them. And
Whereas
you can
question.
see the,
6
hold on,
and
So
9
to my
you
miles.
can see the horizon behind
okay.
the boats and behind the oil
Okay.
rigs.
Okay. Fine. Now, back to my original question. How far can you see on a flat Earth?
There's not a singular number. I just told you. I'm going to repeat myself as many times as I need to until I get tired or you stop asking the same absurd question. It depends on the atmospheric conditions of the day because it's based on opacity of the atmosphere. Do you know what
So you
Okay,
opacity
consider
is
is?
there a
this.
singular
So
number on the
you
rounder?
so
The
you consider
opacity of
15
the
miles as
atmosphere
seeing
is
too
what
far?
makes it impossible to see the horizon on a flat Earth. On a flat Earth, you can never have a sharp horizon because it's always too far to see. On a globe Earth, with it being 3 or 4 miles away, when you sit at the ocean, you see a sharp horizon. That's only possible because it's near.
And if the horizon was at 3 miles, then any object that you see would have to be above the horizon, right? So the
Look,
horizon line should
if you want to
rise up.
respond to what I said, I'll respond to what you say. But you cannot see the horizon on a flat Earth. It's obscured by haze. We see a sharp horizon, and the only way that can happen is if it's near.
That's not true either, John.
Yes, it is. Sorry.
No, it's not. You have a limit of vision.
No, you
And that
don't.
limit of vision based on your yes, you do.
There's
There's a
a limit of
resolution
vision.
limit.
There's a limit of vision due to
Yes,
opacity.
there's
The
a
opacity
okay,
makes the
but you
horizon
saying it
fuzzy
can't be
on a
sharp is
flat
not
Earth.
true.
You
There's a
cannot
resolution limit.
see
Okay, okay.
on a flat.
I'm gonna
You
step up and
cannot see
say something
the.
because I feel like you guys are having the same argument over and over again. During 9/11, I was in Florida, and we can actually see the smoke rising to the point where we thought that it was happening in Florida until we saw the news. That was happening in New York. So if we can see
That's
that all the way
fucking
in
absurd.
Florida,
I'm in
if we can,
Florida. That is absurd. We didn't see any
you're,
smoke.
Well, we
I
saw the
thought I
smoke
was
from
in
Canada
school
when
when
it
it
happened
happened.
here.
Exactly. So therefore, if we can, she can, if they can see it in Canada and we saw it in
And I'm in
Florida,
Chicago.
exactly. So if we were all able to see it, that means you can definitely see further than what you're talking about. Number one. Number two, that also explains that the Earth is round because other than that, we would be able to see more of New York, not just smoke. We saw it rise, not a cloud. We see the cloud part, but I mean, as in the rising of the smoke, that's what we saw.
I don't think so. I'm sorry, but I don't think so.
You cannot think so, but we were in school when it happened.
Well, I'm
Think
saying
so
this
what?
as somebody who understands that it's a globe. You couldn't see the smoke in New York. The smoke may have come to you, but you didn't see the smoke
It
in New
was
York.
not coming to us. It was
I
not
can
coming
see
to us
that.
at
That's a
all.
good answer. Whether we agree or not. That makes
That's a,
logical sense.
it makes logical sense, yes. But however, the smoke was rising. To that's
Clouds
why I said to
moves and clouds moves just like with a storm. The storm will be in one state and then it'll get, start in Michigan and then get to Chicago, then Wisconsin. So that makes sense what
How do
John
you
said.
think that seeing a smoke cloud would prove one way or the other? Hold on a
I
second.
know.
So that's the
It
part where
wouldn't.
you missed as well, because I saw the smoke rising, not just the clouds, the smoke rising. As in, if
No,
you were standing there looking at smoke
you
rise
didn't.
to the top, you would see a
No.
funnel.
How many
We
miles
saw the
between you and the tower?
funnel. Say it
Kenny,
again.
how many miles? How many miles between you and the towers?
I was in Florida at the
Thousands.
time.
How
Yeah,
many
more than
Thousands.
It was
miles
16
during
between you and the
hours
9/11.
away.
tower?
Probably like 1,500, something like
Yeah.
that.
Yeah, not a
Yep.
chance,
Yeah, there's
Kenny.
just not a chance that you saw
Air is
smoke in New
far
York. I'm
too
sorry.
opaque to see that far.
For
Okay.
real.
Well, you can believe whatever you want to believe because it sounds like you just think of
It's not a
skepticism
belief.
anyways.
Air is far too
However,
opaque to see that
however,
far. That's not a belief.
we were in school when it happened. That's how I know. I was in high school. I was in what,
Clouds move.
ninth, 10th grade when this
So
occurred.
was I, Kenny.
Bro,
Okay,
Didn't
so
Kenny,
you were in
happen.
Kenny, you
Florida.
realize you're
Were
lying for
you in
zero
Florida
United
at
States
ninth
dollars
grade
Yes.
right
at
now,
that
by the
time?
way.
Correct. Exactly the same.
And
Yes.
you didn't see the smoke rising at that
It
time.
is literally impossible, and like they said, wouldn't prove one way or the other
Bollocks.
anyway.
That's straight bollocks. Because all of us were literally out of class because of it. We had people who live in New York at the time, and they were trying to check on their family members. We were all standing
Dude,
outside for
maybe
a
you could
So what do
complete
you
see it
mean
from
two or
by
like
three
by smoke
hours
Jersey.
rising?
over
We
this.
saw the smoke from like New Jersey. If you saw it from Pennsylvania, it's damn near a miracle. I don't even know about that. Past
I said
Pennsylvania, you
Florida.
can forget it,
I
bro.
said Florida. I
What
was
Yeah,
in
yeah.
what
Florida.
John what John
Nowhere
said makes sense
Georgia,
because
South
that
Carolina,
Canada
Florida.
fire We
Impossible.
saw it in we saw the smoke in the air in Chicago when the Canadian fires were happening. So what John said, I
So
could see the
re-interrupt
clouds
the
moving.
conversation for this.
The clouds
Facts.
moving makes more sense. But what do you mean by cloud smoke rising? How
No,
can
no,
you see
no. Let's
smoke
not
rising
talk
from New
about
York?
this. Can we continue on with the presentation? Like this is ridiculous. Why are we entertaining this?
Awesome question. This conversation is going absolutely nowhere.
Absolutely nowhere. Yeah.
Well, we've still got the point that the horizon cannot, if the horizon is even 100, if you've ever been in a plane, the horizon is like 200 miles away. It's always fuzzy. I one time saw a horizon clear enough to show the curvature, but most of the time you can't tell because it's 200 miles away. You can't see the horizon when it's 200 miles away, and on a flat Earth, it's
John,
thousands
you
of
can't see the
miles
curvature from an
away.
airplane, no matter how
So
clear the day is.
when you're standing on the ocean, coast of the ocean, you see a sharp horizon on a clear day. That's not possible on a flat Earth.
Dude, that's just not true. Like, you're just
And
claiming
that's
that over and
thousands of
over. Just
miles away.
repeating it doesn't make it true, John. Like, John, we can show you bottom-up obstruction of objects on a table.
No, you can't. I've done that trick. I know how it works.
What? No, I can't. I have the video, John. It's in the side chat. Why don't you look
I've
at
put
it?
a video of that myself. I've done that video myself. I know how it works. So you can't fool me with that.
But John,
Nobody's fooling. This is crazy. The
Well,
level
yeah,
of
that
like
John. So
that
check it
one
out.
is
psychopathy
This
and
is
like
crazy.
self-brainwashing is
That
insane
one
right
is
now.
psychotic. That one
yeah,
where you're like,
yo, Alligator, hold
I
on.
put a
that
link
is
to the
too far.
YouTube in the
Alligator,
chat.
you don't get to talk about
No, that
psychopaths.
one's too far.
John, so check it out. This is what Piers was saying. So it's not the video, the one that you did with them, like putting the camera slightly below the table and then just sliding the
No,
object or whatever. It's not that
no.
one. But it's the same setup, and apparently they just put an object far away and open the door. They just open the door in the room so it could like quote change the atmosphere, and somehow the object starts disappearing bottom up by just opening the door like off in the. I
Dude,
Yes,
didn't
about the
coffee
air mixing.
with the air
dude,
mixing, dude. I think the
incredulity
air
will get you
mixing is
nowhere.
responsible
Yeah,
for
like
iron
you
and
not being
coffee's
intelligent
PTR.
enough to understand like the properties of physics in
You
this
don't. You
experiment
clearly
doesn't
have
make it
no idea who
untrue.
you're talking to, bro.
Yo, see, incredulity will get you nowhere here, man.
It's actually a
You either.
logical fallacy.
Why do you think
Argument
I'm
from
having so much
incredulity.
fun? I have like new guys, whatever the is,
So,
Piezo,
I mean, your
Saint.
claim is that that video is fake. Is that what I'm getting? So, if I bet $1,000 right now that that video can be
Whether that
reproduced,
video's fake or not, this is
Right?
not
That's
the
because most people.
reason the ships and these guys' PTRs are disappearing bottom
okay.
up.
So, is the video fake?
I don't know. I haven't seen the video. I'm not
Which
downloading
So
any
you
video?
haven't
videos.
even watched it. So why are you arguing then? That is
I'm saying
literally
that it's
worse than a
not the
7-year-old.
reason. You see
Just
Coffee and
watch the video.
Iron's PTR. It's
Dude,
not
no,
the
dude.
reason for
Nobody
that.
engage with this guy. Every time he talks, ignore him. He's arguing about something he refused to watch.
I put the link to my video in the chat.
Regardless,
Will you do the
Okay.
same?
Yo, CM, let me help you with
Yeah,
this image
go
you're
ahead and see
trying to
John's
push.
video, though.
The three of you. The three of you are trying to push this image that Lion and Coffee have got up.
I'll send it to
Let
you
me
in
help
Discord,
you.
John.
Just let me improve your eye and add a little bit of discernment to it. How you can tell if the image, like this image here, how you can tell this image might be faked. The answer is that what left of the ship you can see is undistorted. That's how you know you're looking at a really shitty Photoshop job. Because when things, quote, disappear from the bottom up, there's a great deal of refraction and distortion that happens on the way to your eye that is not present in this image. And that's how you know it's fake. Can we talk about something intelligent now?
Yeah, this is like so simple. I totally agree with you guys. It feels like home already. Just dragging these guys around.
Uh,
John's trying to show off because he's got his girlfriend in the audience. He doesn't want to budge on any of this.
I love how the shit y'all can't explain, y'all always deem fake. I just love it.
Yeah, it's like, I mean, to
Hey,
claim
buddy,
that
either
that
you
this
can refute the explanation or go fuck yourself. Okay, I don't care about your
Put
opinion.
the
Hey, that's
video
a
in the
good one.
chat.
Hey.
Well,
Yeah.
the identification is in my PTR. If you just quit being a prick, and you can go there yourself and watch many boats at this very location in this same spot do the same thing.
Put the video in the chat. Let's see it.
What video? Whose video?
Well, whatever video you've been talking about, how we won't watch it. I can't watch it
I
if I
already
don't
put it in
see
the
the
chat
link.
earlier, and I just tagged
He
you
did
in
twice,
Discord.
Joe.
Is it in
Yeah.
the chat earlier?
Yeah, it's also in Discord. I just tagged you. Check your Discord notifications.
Yeah, it's a cool video, but it's pointless because you can't match the conditions to everyday, life
It's
that
not
we
prevalent,
see.
hey? Is it not prevalent?
Just not.
Just put it in again. How far back do I have to go? Is it
Did,
okay?
John,
Maybe this
go
is it.
open
I
Discord.
put it in there. It's in
Okay.
maybe this is one of those things when you're like looking at like an image and it has like two different faces in it, and sometimes my girlfriend's like, "Hey, can you see that face?" And I'm like, no, I can only see this other face." Maybe that's how they're looking at it, and we can see it. Like, obviously, this is just how it works. They're like, no, 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 no. We see the other face. We can't see the way you're looking at it.
You guys know those little white squares with like a cutoff on the edge of them that they tie? It's like a bread clip. It keeps the bread bag closed. It's like a little white square with the little teeth on it.
Yeah, yeah, yeah.
They're like, how thick is that? Maybe half a centimeter or something?
Probably.
Yeah, they put one of those on a table along with a couple of other objects of similar size. And they put the camera right on the surface of the table. And those are the objects that are being obstructed bottom up. They put it on the other side of the table and they zoom in really far. So it simulates objects near the horizon. Okay.
Yeah, yeah. I've never met you before, Piso. Name the 3 types of angular merging.
Guys, shut up, alligator. What
Uh,
Joe doesn't understand
I've
is that
never
the
even met this
atmospheric
guy. He's trying to
conditions would
explain it to
actually
us.
extend the
Just give him a
field of
shot.
view, not shorten it. The water vapor in the air would actually refract the light even more, let you see even further. What this atmosphere thing is just completely backwards, dude. This is what I'm saying. Your video, whether it's real or not, is completely irrelevant.
Okay, give us the 3 types of angular merging, Piso. It's okay. I was telling CM, there's resolved where you can see both of the objects. There's just resolved where the merging starts to begin, and then there's not resolved where you can't see the object anymore. And he's having an issue with this just resolved portion. Look at his PTR. That's what he thinks. That's what this. He's writing a theorem on this. This fucker's writing a theorem on his PTR.
When I click
Is
on the
PTR
link,
like
it
a
says the
feature in
video is
this
no
app or
longer
something?
available.
Oh yeah. Oh, his image. His whatever the image is called,
Okay,
PTR,
so
his
what's the
personal image.
issue?
He's
What's
writing
the
a literal mathematical theorem that he's going to post on his PTR about what's going on in his PTR.
Who?
Okay, so what's the issue you guys are pointing out? Because I was confused because at first I guess the three merging angles that you were just describing. That's why I asked earlier, I think, what's his name? Pizzo, I believe. I might be mistaken. I was like, so are you saying we can partially see, not see it, or can we see the whole thing? He never
See
answered.
what? What are you asking? Can you clarify your question? Sorry if I
When
didn't
you're
answer your
talking
question.
about the 3 mile thing, and as if the globe, if the
The 3
sphere
miles.
theory, yeah, you're
Oh,
saying you can't see
okay.
that.
Oh,
So I
yeah.
was like, what do you mean you can't see? You can't see the bottom of the ship or the ship in its
Yeah,
entirety?
sorry. Let me explain. So 3 miles is the point where the horizon begins. Okay, so once you go beyond that, things start to drop. Okay, so for an object that is beyond 3 miles,
Did he go out or is it me?
He went out. Can you hear it?
I'll finish this sentence. For an object that's beyond 3 miles, you lose the bottom of it. If you're
That's what I
6 feet
thought.
tall and there's no refraction.
Exactly. Even then, that's your geometric
sorry,
horizon.
my
You
app
don't
crashed. Can you hear
actually
me?
see the geometric
Yeah,
horizon.
yeah, yeah. Can you hear
Yeah,
You
us?
you're
only
back.
see the
You're
You're
back.
back
line.
There you
now,
go.
but you
Yeah,
went
sorry,
out for a second.
my app crashed. Yeah. Once you go beyond 3 miles, the object will begin to lower. So you can use a calculator is the easiest way to use it. But as dude said, you go to the other side of that midpoint because that's the bulge. Like you imagine, like you're on a surface of a sphere. There's like a the curve is in the middle, the top of the basketball is in the middle, you're on the right side, the other object's on the left side. If you're 6 feet tall, then that middle of the basketball will be 3 miles away, and then 3 more miles away, somebody else that's 6 feet tall will be just disappeared, right? So, like the boat example, as soon as you go beyond 3 miles, you'll start to see the bottom of the boat if it's a ball, the bottom of the boat will start to disappear. And if it's a 6 foot tall boat, once it goes to 6 miles, it should be completely gone.
if there's no refraction. And it will be gone behind a perfectly sharp, not perfectly, but a very sharp horizon, which is not possible on a flat Earth for
Well,
reasons
once again,
that anybody can look at. Horizons 200 miles are extremely fuzzy, and on a flat Earth, the horizon is thousands of miles away.
John, you're just
Correct.
positing stuff. You're just
I'm
claiming
not positing stuff. Tell me why that's
Yeah.
wrong.
You're not
On a
quantifying
flat
First of
anything
all, it is
Earth,
flat,
either.
you
and we
look
can see the
out,
horizon
you
like
can
that.
Everything
see,
you
if
say
it
is
weren't
carrying
for
zero
haze,
weight.
you would see
Yeah.
forever.
You're saying what
John,
we would see, but we do
your
see that.
points are carrying zero weight because you're quantifying nothing.
Quantify. It's very simple. You yourself said
Uh-huh.
atmospheric haze gets in the way. Atmospheric haze begins
Right.
at 15, 20, 30 miles, you start to notice haze. By 200 miles, look at it from a plane. Go up in a plane, look at the horizon, which is 200 miles away. It's incredibly hazy, except on the clearest of days.
Yeah, you can see
Standing at the
further the
seashore on
higher
a
you
clear
go.
day, you get a sharp horizon, and that sharp horizon is because it's near.
Why does the sharp horizon have anything to do with whether the shape of the ground is flat or curved?
Because you don't get a horizon 3 miles away on a flat Earth.
Regardless of what distance it's at, why are you saying it would not be sharp?
No, because on a
Would
flat Earth
Jesus?
it's
Do I have
not
to go through
vertical.
this again? Because distant horizons get fuzzy or not visible at all due to atmospheric extinction. You yourself said that.
I didn't say they don't get fuzzy. I didn't say that they
I
don't
didn't
get
say
fuzzy.
they get fuzzy, but you know they have to because
No, they
at
don't.
some point you can't even see the horizon.
On different days, we can have sharp horizons that allow
Yes, and
objects
it's
to be
not
seen from different
possible
distances.
on a flat Earth because on a
You're just
flat
dude,
Earth,
that's a
the
tautology.
horizon is very
You're
I
literally
mean,
just repeating a
away.
tautology right now. You
Okay, hold on.
saying it
Pizzo.
doesn't.
Quick,
I mean,
can we
Pizzo.
please finish Virgil? Can you stop
Real quick,
interrupting
y'all.
over Pizzo
Real
when he's
quick.
trying to
You
make a
guys
point?
could shut John up, right? You could definitely shut John up if you define what creates your horizon and how it creates that sharpness.
There's not one singular variable that creates the horizon. It's a amalgamation of many different things. There's a
Dun dun
combination.
dun.
What is it beyond the atmosphere?
You have, first of all, you have optical compression from pure geometry. Second of all, you have atmospheric effects. So when you combine all the different atmospheric effects along with the geometry of the compression, bottom up to top down, those two things coincide, or those two groups of things coincide to create the conditions for your horizon.
Word salad. That you don't get
It's
a
not word salad
sharp
just because you don't
horizon
understand
that
it. That's
way. If you want a
hilarious.
sharp horizon,
John, this is the same thing that you do with Witsit and every other person that you can't argue with. You say
yeah,
word salad when
I
they explain things to you
argue
very clearly.
effectively.
Pizzo.
Talk to anybody
You
talk to anybody listening.
What part,
Ask them if they
specifically, what
don't
part of my statement
understand
was
the
word salad? Unless you
idea
can explain what
that
was
if
word
you,
salad, it's irrelevant. What was
so
word salad?
another way to get a sharp horizon is to have it be
Hey,
nearby
you can't
hills.
just talk past
Nearby
me and act like you
hills,
have a point.
nearby houses, they all create sharp horizons.
John, this is not, you're not going to
create
do this,
sharp
buddy.
horizons because they're near.
You're not going to do this. What part of my statement was word salad? You don't just get to say word salad and talk through me. We don't behave
Go
like
say it
that
again.
here.
Let's hear it again. If
No,
it's so clear, you
you
ought to be able to repeat it.
claim, so tell me what was word salad.
Well,
I
you
bet
repeat
you
it.
he
Let's see
can't
if you can
say it the
repeat it.
same way he did last time. I
What part
promise you
of
he
it
can't
was
say
word
it the
salad?
same way he did last
Even
time.
if you can't, Coffee, settle down for a second, because if John can't repeat it at all or generalize it at all or even come close to it, that's even worse.
I could,
Settle
bro.
down.
Alan, you heard what he said. You know he damn sure didn't answer that question. You know it just like I know it because we were both listening.
That's right. He said
Yeah, Alan doesn't
talked
know that at
about
all.
geometric compression. He talked about atmospheric extinction. None of
So what
that
part was word
creates a
salad?
sharp
Yeah, that's
horizon.
it.
In fact,
So where's
it
the word salad?
obscures a sharp horizon.
Hold on, what's the definition of
A
word
sharp
salad?
horizon occurs when the thing that is creating the horizon, like a neighbor's rooftop, nearby hills, The horizon of the Earth
Hold on, John.
is near.
A word salad is a confused or unintelligible mixture of seemingly random words and phrases. So can you tell me what part of my statement was word salad, please?
Well, I just did again. You said a
No.
bunch of words, none of which answered the question how you create a sharp horizon.
That wasn't the question. The question asked to me was what conditions create a horizon?
No.
Create the sharp horizon.
Okay, of any
And
opacity or
you
sharpness.
said
Some
atmosphere,
days the
which it
horizon is
definitely
sharp, some
doesn't.
days it's not sharp.
Dude,
The
all you
fact
said
that it's
was
Right,
sharp
and it
atmosphere.
sometimes
can
and not other.
never be
Yes, yes.
sharp on a flat Earth.
That's
All you
not
said
true.
That's
was
Prove
the
that.
problem.
Prove it,
atmosphere and
John.
perspective. That's all you
Yeah,
said.
you're making that positive claim, so offer the proof for it, please.
The
I
proof
don't
is
agree with your claim.
this. The proof is simple. You a horizon that is far away is obscured by atmospheric extinction. If it's more than 200 miles away, typically, and once again, you can check this out from an airplane, you won't even be able to see the horizon because it's so fuzzy and obscured by the haze. The only way you get a
Wait, are you
sharp
assuming we can see for
the
200
only
miles all the
way
time?
you get a sharp horizon is when it's nearby and not obscured by atmospheric extinction.
Wait.
You've seen this over
John,
rooftops of your neighbors, you've seen it
wait.
over nearby hilltops,
Dude,
and you
what, can
see
you
it
just
when you
not
stand
stop?
on the ocean shore of the
Oh my
globe
gosh.
Earth.
All right, do you think we can see forever, John, if we were on a flat plane?
Yes, you can see
Okay,
forever if you don't have
we might as
extinction.
well just discontinue
Fuck, you
this.
are
If
retarded.
something is bright enough
How do
and
you
nothing
calculate
is
the distance to the
blocking the
horizon on a
light,
feet, John?
you will see it.
God, you are so retarded.
Yeah, this man thinks you could see forever if we were on a plane. This is hilarious.
If something is bright enough to see and nothing is blocking the light, you will see it.
Nothing is blocking the light.
The air.
So I guess we can't see forever.
Air.
What about resolution limits, John? You don't think that
About
there's...
them. You want to change the subject? Fine, let's change the subject.
No,
That's fine. I can talk about resolution limits.
Yeah, so you just claimed that on a flat surface you could see forever, right? We can demonstrate to you on known flat surfaces, such as hallways, such as warehouse floors, such as open fields, that things disappear.
That's nonsense.
That's not, so now you're just denying reality. You've been shown the videos before, so now you're a known liar because I know for a fact that you have seen these videos. They've been shared with you in rooms I've been in when you were there.
Well, here's what happens when something gets very far away. It gets too small to be able to distinguish.
Oh, so a resolution limit.
Exactly. So here's the thing: you're not.
You think things are too small to see? Wait. No, John, stop.
Too
You're not
small
going
to see.
to interrupt
Too
me.
small to
You're
resolve.
not going to interrupt me.
Right.
I'm not. Look, if you're going to interrupt me, I'm just going to make noises so no one can hear you. We're going to take turns. You're not going to act like a child in here. This man is like a 60-something-year-old retired grown man with a PhD, and he can't control himself better than that.
You go, then I'll go.
John, you usually
Thank
can
you.
control yourself better. I would like to hear this productive conversation that's going on. So show a little restraint, man. You're usually pretty good.
Yeah, so when I see a person walking across a field and their legs disappear up to their lower thigh, but I can see the rest of the person, that person's clearly not too small to be seen, so it has nothing to do with being too far away to be too small. It's just their lower legs that are disappearing. Why are their lower legs disappearing across a warehouse floor or a field?
Well, that doesn't happen. So give me something
John,
that does.
John,
When you see a
this has been
ship that
demonstrated
you
to you.
can see,
So if I produce
there
a
are
video
cases
where that's
of,
shown, will you leave this chat and never come back?
You keep talking. Let me know when I can talk.
Okay, so if I produce this video where a person can be shown to disappear, their legs disappear, then are you going to just like leave this chat and never come back? Are you going to say it's a fake video? What's going to happen? Can you tell me what's going to happen? What's the next step?
So when an object, a person, say, if a person disappears behind if the bottom part of a person disappears and you can still resolve their upper parts, it's because something is blocking the light from the lower parts. That's the only way that happens. Now, let me address the issue.
Why would the light be blocked from the lower parts when it's just traveling in a straight line, John?
light travels not necessarily on straight lines, but if there's nothing blocking the light, you'll see it. And that is also true for things that get too small to resolve. If your person walks away from you holding a laser shining at you, there'll come a point where you can't make out the person at all, but you'll still see that laser. If it's a flat surface, you'll see that laser until it gets so far away that the laser light gets too dim to see. If something's
So
bright enough to see and there's nothing blocking the light, you will see it. That is just grade school, optics.
you're telling me that the line from a person's thigh, which is a couple feet above the camera, to the camera across a warehouse floor or a field is getting blocked by something?
If you're not seeing it and you can resolve the top part of the person, then yes, that's the only way that can happen.
But you can see their feet when they're close.
Okay, so?
And then as they continue walking across the field, like you can pick the camera up off the field and you can show, hey, this field is flat. This warehouse floor is flat.
How do you know that?
How do I know that the warehouse floor is flat?
Yeah, I mean, I agree with you that it should be. But if the person's feet and lower legs have disappeared and you can still see their upper body, resolve their upper body, then that's because something is blocking the light from their feet.
No.
Things don't melt into a flat surface with nothing blocking the
How
light.
much deviation
That just
from
doesn't
flat?
happen.
How much deviation from flat would be required to block 2 feet of their legs?
Well, 2 feet's worth of blockage, right? You'd have to have something blocking the lowest 2 feet.
So you
of
think
light.
you think a football field drops 2 feet from one end to the other?
It shouldn't.
Yeah. You think a warehouse floor drops 2
It
feet?
shouldn't. I don't know. If you have a picture, here's what I know
Okay,
is
buddy.
that if you have a picture of a person and you can see their upper body, make out their upper body, and you can't see their lower body, it's because something is blocking the light from their lower body. This is not rocket science.
It's not something blocking the light, John. It's the fact that there is a resolution limit for the sensor, just like there is for your eyes, which are a sensor.
Well, if you
and based on the optical compression, in the areas closest to the ground, there's more compression. The areas closer to the ground have to compress more to come up to the line than the sky does as it comes down. So those areas compress more, and those parts of the image get lost.
That's ridiculous. Nobody in here with any sense has any trouble seeing how ridiculous it is. If you can resolve the top part of a person, you can resolve the bottom part of the person if you can see it. The only reason you won't see it is if something is blocking the light from the lower part of the person.
Yeah, that's just not true. There's nothing
Well, the light is
physically in
bouncing in the
between.
camera.
There's
So
nothing in
there's a
between the
mirror in the
person.
camera, so it depends on the lighting. I do film work. Film and photography is primarily all about lighting. Even your eyes work just like a camera lens. So it's like, what's going on with the light here?
Yeah,
Your
I mean,
eyes work
dude.
just like a camera. You put a camera in front of your eyes, it uses the exact same light that is coming to your eyes. When you there's that classic thing, right? Use the P1000 to bring something back from over the horizon, as if the light from the horizon, light from that object is there when you put the camera there, but it's not there when you take the camera away. That's ridiculous. The light coming to your eye is not changed by putting a camera in front of it.
No, but your eye cannot resolve as well as the camera can.
That's
There's
right.
not as many
Can't
pixels.
resolve it. That's right.
So that's
but
why.
If you are resolving it and you can't see it, it's because something is blocking it.
No, John, nothing is blocking. We can verify that there's nothing because we can stand up, we can take the camera up off the ground and show that the person comes back into view, and there's nothing in between us and their legs.
Well, if the person comes back into view and you could resolve the upper part of the person before, the only reason it came back into view is because you lifted the camera above the obstruction that was
There's no
keeping you from
obstruction,
seeing it
John.
before.
Oh my gosh, bro.
You can say John, John all you want, but there's not a person in here who's going to tell me that what I just said sounds ridiculous.
All right, anybody
If
that's
you
in
can
here, if
make
they
out,
actually
if you can
care, they can
see a
test it for
person from the
themselves.
waist up and you can make out that that's a person from the waist up, then you're resolving them, and you can
Here,
resolve their legs too if you could see them.
look,
But
guys,
you can't
go to your
because the
nearest
light
parking
from
lot.
them is being
Yeah, yeah.
blocked.
Anybody can verify this. Go to your nearest parking lot, okay, and just put your camera down, put it on record, make sure it's leveled off, like put it on like against a rock or another camera or just anything to make it stand up, and then record yourself and just walk across the parking lot as far away as the other side as you can. And then come back and check your recording and
The
you will
camera
find
has a mirror, so the light is bouncing off the mirror. The mirror is slanted in that camera.
that. What are you talking about?
The
A
camera
mirror?
has a mirror, so when you're talking about it, you're walking, so it's not like so the disappearing part is because the camera is slanted. John is damn near he like 99% correct when he's saying a blockage. So it's not blockage, it's just a damn mirror in the camera that's
There's no
slanted.
mirror in your camera. What
It
do you mean
is.
a mirror?
It is. It is
Yeah,
literally.
she's talking about a classic DLSR.
I do
I
film
think we all
photography. I
use
went to
mirrorless
Columbia
nowadays,
College.
but
Yeah,
there used to
and
be
the
mirrors
light
in
is bouncing off of
DLSRs.
the mirror.
Yeah,
So of
there's no
course it's going
mirror
to
in
do
your
that.
phone camera.
Nigga, I'm talking about a real camera, not a
Okay, you
fucking
can do it with your
phone.
phone camera. Any sensor. They're all just sensors. There's not anything fundamentally
Wherever the
different other than
the
having
light is
additional
bouncing
components.
off of something. So the light bouncing off of something is what's causing that
Yeah,
illusion.
you're literally making this up as you go right now.
He was saying blockage. I was just saying it makes sense, but the blockage isn't really correct. It's really the mirror, and it's bouncing. The
Yeah,
light is bouncing off of something, even with your
Well,
that
eyes.
even if there was a
I'm
mirror,
just going
which
to
there's
say I
not, that
don't
wouldn't do that.
understand that either.
Yeah, that
Just
doesn't
be
make any
open.
sense.
Well, that's what's happening.
Why would there's not a mirror, but even if there was, why would that cause the lower half of a person's body
If
to
you had
disappear?
more light, take that same video, the person walking off, add more light to that camera. Take a reflector, put it by their leg. I guarantee you, you'll all of a sudden you'll see the fucking legs. I do this. This shit, the camera is all it is the light bouncing off of something. It's angles, the same way your eyeballs are working. I've been doing
So
this shit
why would it not
since the early
pick up the
2000s.
lower part of their legs? A phone camera doesn't have a mirror, so your mirror explanation doesn't work if there's not a mirror. So what's happening?
Take a the light is
This is a
still
bad
bouncing off of
argument.
something.
Yeah,
Take
it
a
is a bad argument.
reflector. Take a reflector. You can do this shit with sunlight. They do it.
So I saw a video recently, I think taken on a football field. Maybe you've seen it. I know it's been
I know
making the
you've seen it.
rounds.
I know. I
And
was there when it was shared with you.
and oh yeah, and you know it's interesting because to my eye, I looked at that and I said, well, you know, a football field shouldn't be curved, but it sure looks like it is. I mean, when I looked at that video, the first thing I
Isn't the
saw
lens curved?
was a football field that looked like it was convex.
Didn't you say that there had to be 2 feet of curvature to lose 2 feet of the person's legs? Just a
Yeah,
second
there
ago?
would have to be, well, I don't mean what you mean by 2 feet. There would have to be 2 feet of blockage, right? The only way you'd lose 2
Yeah.
feet of somebody's legs, if you can make out the upper
Oh,
part,
what's the
is
blockage?
There's
if
definitely
it's
not 2
being
feet of
blocked.
blockage in that video on that football field.
Right.
And
So
by the way,
you're
the
losing
convexity of
light.
a football field is off to the sidelines, not towards the end zones. A football field is flat as you go straight across. It's the edges of it taper off to the side so water can drain off, John. But from end zone to end zone, it's straight.
Well, you may say that. I'm just saying that when I looked at that video, I was struck immediately by the fact that it looked like it was convex. Now, I don't know how convex, and frankly, I didn't watch it to the end. So if you're going to tell me that 2 feet of the person's legs disappeared, I'm gonna say fine, you know. But if you can still make out the upper part of that person's body, then it's just not rocket science to understand that the only reason you're not making out the bottom part of that
So,
person is because the light from it's being blocked. I mean,
so
it's
you're
just this
telling
is
me by
Blocked by
really
what?
just grade school
you're
optics.
telling me by the time he
What's
gets
it being
70
blocked by?
yards away that he's encountered 2 feet of drop? in
Well,
70 yards?
here's what I'm telling you. I don't know because I didn't watch it beyond just looking and seeing the curved football field. But
What's
if
the
you're
light being
telling
blocked
me
by?
that 2 feet of that person, the lower 2 feet, disappeared,
Well, I'm glad
then
that you
I'm
don't
telling
know
you
because
that's
I do know,
because
and it's
it
not.
was
It doesn't
being
drop.
blocked from your
Yeah.
view.
So if you don't know, John, why do you keep arguing? You're saying you don't
I'm
know, and
not
you're
arguing.
continuing.
I'm just telling you that the only way you don't when you're looking at something that you can
Yeah,
resolve,
this is dog
the
crap,
only
dude. This
way
is
that you
dog snot.
can't
This whole conversation's
you
awful.
can't see it is if the light's being blocked. There's no other way
You
for a
don't know if a field
resolvable
for sports is
object
curved or not,
not to be
John.
resolved.
You don't know if a sports field is curved or not.
I know that a sports field is not supposed to
Hey,
be, but
yo,
let me just ask
You
in his
you,
don't know
can
if
you
the
defense, he
be
don't
curve
know
is
shit
honest
2
about
feet over
enough?
sports.
between the
Can
end
No,
zone
you
and the
in
be
70
his
yard
defense, he
line.
don't
honest
know shit about
enough?
sports.
Can you be honest enough to admit that the first thing you see in that video is a football field that looks like it's curved? That's what I saw.
Maybe you've never been on a football field, bro. On the
Oh,
edges of the
for God's
field,
sake.
it
Now
curves
you're
off so
just
the
being
water can drain
dishonest
off.
now. Anybody, put the video up. Let anybody else watch it. Put the video up.
I'm
I
trying to
have to
find it.
go, frankly. I have a dinner date at 7. So I have to go, and I'm
I already
sorry
acknowledged you
about that.
saw it.
But put that video up, let anybody else watch it, and tell me that that football field doesn't
We're
immediately
both
strike
describing
you
the
as
same thing.
curved.
John, it's not curved front to back. It's curved off
You
side
can
to
tell me that
side.
all you want. Put the video up, let people watch it.
Do you think that a football field drops 2 feet in 70 yards?
Put the video up, let people watch
Oh
it.
my gosh, bro. I would love to.
To
I'm
say
trying to
that
find
you
it.
don't know if a football field is curved proportional to the loss that you're trying to say, while simultaneously saying to say drop over distance on a curved sphere is a geometric property of that, but you're not willing to say that the football field would have to be curved proportional convexly to do what you're saying. Like for that, you're like, oh,
Yeah.
I'll leave it to the
Put
viewer to
the
Yeah,
look
the
at it.
football
That's
field.
the
video
I mean,
most
up,
in his
let
disingenuous
worldview, hold
dog
on.
shit
people watch.
I've ever heard in my life, dude. That's so fucking crazy.
It's hilarious, bro. The football field would
Put
have
the
to curve the
video
same
up,
amount as the Earth would to create
let
the same drop
people
the Earth does.
watch.
Like,
Lord, would it? What the hell?
yeah.
Why
So
would it?
if the Earth,
It could
like
just
if
be uneven. Like,
no,
what the
no.
hell?
Hold on a second, Coffee. Understand. If the Earth has a
Put the
horizon,
video up.
John, stop interrupting people. If the Earth has a horizon
Put
and an
the
object is 2 feet below the
why
horizon,
you
John,
up.
stop. If something goes beyond that horizon, right? If their legs, let's say their legs disappear beyond the horizon on the Earth, and it's
What?
because 2 feet of their legs is under the horizon line. Okay, that makes sense, right? This man is saying that that is the same explanation that causes 2 feet of this man's legs to disappear as he walks across a football field when you put the camera really close to the ground. The problem is we know that fields are level. There's not 2 feet of drop from
Put
one
the
end zone to the
fucking
other end
video
zone.
up.
There's not 2 feet of drop from end zone to end zone.
Putting the video up isn't going to
So
change
explain
your
explain
argument,
us
though.
what's
Oh,
happening.
oh, yeah. John thinks that there'll be curvature on a football field. Can you fucking believe that?
So why are the
I
legs
can believe it.
disappearing?
He thinks that there's 2 feet of curvature on a football field between the two end zones.
Can you believe that?
I can believe John believes that.
I
Put
know.
the video up.
When he told me this, I could not believe that this man taught children and has a PhD and calls me stupid,
Put
motherfucker.
the video up.
Oh man, dude. He thinks that there's 2 feet of drop between the
If
end
he
zones,
puts the
bro.
video
I
up,
know
does
he
that change
does. He does.
anything?
Why doesn't anybody else in here want to see the video? That's what I
Oh
want
my
to
What
know.
gosh.
where's the video?
I want to
What's
see
the
even put it into
blockage?
one of my
What's the
videos.
blockage, John?
You got it on your video, Stone? Can you find that video of yours? It'll be easier.
Yeah, it's Fe
I don't
Stone.
want to see
It's
another.
called
I want to
Hey
see the
NASA
football
Liars.
field video. Put it up. Let
Once,
people watch it.
Actually,
Let
maybe it's
them
not
make
too
up their
long. I
own
could check
yeah,
that out.
minds.
Stone's trying to get me to it. So if you'd stop interrupting, we'd be able to put it up.
Let me
Where is
check
it,
which one
Stone?
is. Let me check which one it is. It's either Lots and
Okay.
Longs or Hey NASA Liars.
Okay.
It
Yeah,
should be a
Stone's gonna
real
save the
tough
day.
one, guys. Is the football field curved, or is there an optical effect doing it? It should be real hard to figure out,
Yeah,
man.
there's two options in this question. You're right. Is the football field dropping by 2 feet between its end zones, or maybe there's just geometric optics involved where there is optical compression bottom up?
Oh
We're
yeah,
gonna see.
it's folding. It's folding and bending and unfolding at the same time. Don't forget the unfolding part.
It's like, y'all ever been to high school before? Did ever here graduate high school? Did y'all ever go to the football? John probably didn't go to the football games, did you, John? John? John
No,
left.
but why does that matter?
John left.
He probably went to dinner now, but in any
Oh
case,
yeah, I forget. If you turn the heat up too fast on John, he'll just go into another room. But he'll always come back.
Okay, I found it.
it
Oh, you
is
found it?
different
Perfect.
putting it
Put in
in
that
Yeah,
side chat,
it's
boy.
it's in lots and longs. Let me get you the Addy. What the fuck?
Now I'm gonna find go to the timestamp, and I'm just gonna sit here and watch it again and laugh. And then I'm gonna put it in Discord and tag John in it.
Okay, there's the video, and it's at 46 seconds.
46 seconds. Word.
Oh yeah.
Oh my gosh. You could literally see the freaking goalposts in the bleachers, bro.
He's almost down to his elbows. It's a great video.
Oh yeah,
Had
you're
a good
right.
time making that.
Yeah, it's like
So it's more than 2
yeah.
feet. It's like 3.
Oh yeah, it's more than 2
Oh
feet. Gosh. It's like up
It's
to
like
past
3.
his waist. You could literally see the
It's up to his
freaking
elbows almost. It's like 3. The guy's
goalposts in the
tall.
bleachers, bro.
Clearly, you can see how tall that fucking guy is. That's why they picked him.
That's hilarious. At 46 seconds. Word. So everybody take a look at that.
Oh my
My
gosh, is
my
is he
gift to the
calling? Is he calling just resolved curvature? Is he calling the angular merging curvature?
What? John is
Yeah.
saying that in order for this person to disappear, like their lower parts disappear, there would something would have to physically block the light between the camera and the lower half of their body. So
Oh
when
yeah,
they
yeah.
when they
Have you heard
disappear up to their
CM's
waist,
theorem? Where's he at? Oh, he's not up here no more.
when they disappear up to their waist, like in this video, that video up to their waist, or that disappearance up to their waist, all the light from their waist down would be getting physically blocked by an object in between.
No, it's the surface of the thing in front of it, right?
Yeah, I just watched that video. That gotta be a physical obstruction. That has to be, or an angle change within the camera. That's one or the other.
It's simply the
The
damn
only reason
lighting.
I can
You could
think
take
of
that same video with different lighting and it'll have different effects.
I mean,
Coffee,
y'all,
you
they
think
have
of the
they've made
goofiest
these
fucking
videos in
excuses,
warehouses
man.
too. I hope y'all know that.
Yeah, but did they change the lighting at any point? Is it still just the same? Is it?
How would changing the lighting change
It would definitely
geometry?
change.
So
So,
hold
like,
on.
if
So
I have
okay,
barn doors on a video, I can make you down there completely disappear, right? Because I'm directing the light at a certain point. If I open up those barn doors, I'm going to see more of you. That's why I asked, are
Yeah,
is it
but
the same video?
that don't mean
this is
that they're
AI.
disappearing yet, love.
Yeah,
That
this
just
is
I'm
means
not
they're out
saying
of
that
the
they're
light.
right.
That's all that
So,
means. But
exactly,
I
they're
get
not
what you're saying,
disappearing,
but
they're out of the light.
it's not comparative. That's what I'm trying to highlight here.
yeah, this
So,
person
what's
is
the
outside in
blockage? Well,
sunlight, so
John
I
not
don't
here
think we
no
got a
more.
problem with light here, lady.
Did you see when the dude finished walking, then starts walking back, then disappears like a blip for a minute? Did you guys see that? Back, he turns back towards the camera, and then he like blips out. Like I
Yeah, he just
swear.
ducks down. That's all he does. He just gets low
I
and then
rewatched
stands up
it.
again.
I didn't see that.
I
Well, I
like this
sped
guy.
it up. It is sped up, right? Like you're looking at fast forward version of the actual video,
I
right?
looked at a guy blip off like there might have been an object cropping in front
Well,
from a
I
production
bet
angle.
aliens did it.
I think a production did it, like post editing.
Dude, I sped up the clip to use it in my video. Are you hearing me?
That's because there be mirrors in them cameras, though.
You remember when we started
The
and
light is bouncing off of something, period.
we quantified all this with the difference
And
between
our
the models?
DSLR camera, well, you said something about a phone, still, it's glass, right?
I had to change, like no one could hear me anymore.
Here you, bro.
Well, so light not bouncing. So what happens with a prism? Okay, I'm done. Never mind.
All right, I saw it. I saw him duck down. I rewatched it. I'm a little hard of seeing. Excuse me. He did duck down. Thank you.
Yeah, he
All
ducks
right,
down and
good to
stands back
go.
up just to show
Good to
you that,
go.
you
A lot
know.
of eye protect. Yeah. It's a small phone. Excuse me. Yeah.
But
Yeah,
once again,
you guys
we know
understand wave symmetry, right?
what.
Anyone? Going once, going twice.
Well, just real quick, I want to point out at the end of this video, if you start at the very beginning where this guy's feet are in the
That
frame,
wasn't
right?
funny,
You can
Coffee.
see his flip flops, like you can see his feet flat on the ground. We know that we can see right above the ground. We're above the ground. We know we're above the ground. The grass is trimmed. There is nothing in between us and this guy.
But
The ground is not dropping by 3 feet, bro.
do you understand wave symmetry?
Is that relevant? What do you mean by wave symmetry? How's that relevant to this conversation?
The
Just make
uniform
your point.
the uniform propagation of space and free the uniform propagation of light in free space. I think that just the image alone, it breaks all of it, right? Because if you have a loss of resolution, it all creates a diffraction pattern given a airy disk. We all see through little circular apertures, so it's just physically impossible, right? Even caricatures have circular apertures, so
Okay.
it's physically impossible, right, in our reality, to get a loss of resolution and a hard cutoff, right?
Yet
Unless you're gonna
we
rewrite,
see a
unless
loss
you're
of resolution in this
So,
video,
so,
so it's
so
I,
what?
probably not
So
that's
impossible
when
in
just
you
not what it
reality.
meant,
is. It's
so
just
when
not
you
what it
meant
is.
waveform symmetry, you really meant key mirror image y-axis, origin symmetry, half wave, negative cycle matches, and eliminated specific harmonic coefficients. Is that what you meant, or
No,
which one of these?
I don't know what you're talking about, alligator. But to try again, just give me a second.
So you don't even know what you're talking about at this point.
So here's what I can tell you. If we start with the sensor, the camera, right? There's like a center. There's a center, like a straight line directly horizontal out from us, right? Well, we're going to treat that as like the center, right? Okay. Things that are above the center, things that are below the center, things that are to the left of the center, and things that are to the right of the center. We can divide the image into 4 sections, top and bottom, and then also left and right. So half and half and half and half. All 4 of these have to symmetrically converge to that center point in the amount of information that they can carry. Now, when I say information, that's your image, okay? So if we think about the upper half, what's in that upper half? Every single thing that exists from the sky all the way to the ground. So like hundreds of miles or whatever is on the upper half of that image. Okay, cool, got it. Now, what's in the lower half of that image, right? We have all this stuff from the ground to the top, right? It's like a couple feet. So all that stuff on the bottom has to converge up when all that stuff on the top has to converge down. Same thing from the left to the right. Now, this makes total sense when you think about how things disappear from the bottom up, like in this image, because you're stuffing so much stuff into a tiny space on the bottom half, where on the top half you have all this space. So that you have all the majority of the image is
are
stuffed
you
into.
explaining angular compression?
Yes.
Brother, I could just beat you to that. It just doesn't work in this instance. I'm sorry, buddy. Like,
That's what's causing him to
I'm
disappear
so
in the camera.
sorry. The reason being, right?
You can't even explain
Um,
why he's disappearing, and I'm giving you the answer.
it has to be an obstruction, but it's just is what it
There's
is.
not an
Unless you're
obstruction.
willing to rewrite Maxwell's
You
laws,
can
bro.
physically
It
see
just
that there's
is
not an
what it
obstruction in the
is, my brother.
video.
You're
You
not
can
gonna
see
get
that there's
that
not.
much cutoff given angular compression. It's
This is
just not.
crazy that these people don't trust the evidence of their eyes. You can watch the video and see that there's not an obstruction. It is confirmed that it's not there. If there was an obstruction, you would
And to
not
see
see
it
his
another
feet.
way. But I
Well, you wouldn't see
understand
his
what you
feet.
guys are saying. It's really easy, but I understood this
It's
immediately.
either a physical obstruction or that sensor is out of the way of his feet. That's
Dude,
all it is.
dude, if there
That
was an
that camera
obstruction, it would
may
be
be
present the
angled
entire
upward,
time.
right, to where his feet is cut off by the field of view of the camera. It just is what it is, bro. There's no way you're gonna get that level of detail resolution, right, and have the bottom be cut off, right, and we still apply by the laws of wave symmetry.
So
There's
why
no
can
way.
we
There's no way in the world. No way,
why can we see his feet at the beginning then if there's an obstruction? His feet are
bro.
right on the ground. They're touching the ground. We can see them.
Bro, I just gave you two reasons, right? It's either there's an obstruction, and if there's not an obstruction,
There's
the
not.
camera lens is angled up at a position where the camera's field of view cuts off his feet after a distance.
If the
You
camera was angled up to where it couldn't see, then you wouldn't see the ground. We know that the ground's visible right in front of the camera, and the ground's
you
below the camera.
you wouldn't
Hold
just
on.
see the
Let me
ground to a certain
finish.
distance, my
Let
brother.
me finish. The camera is above the ground, and we can see the ground below the camera. The guy is above the camera. So if we can see what's below the camera, then why can't we see what's above the camera?
Bro, all you got to do is angle it up. If you just to see a little bit less floor,
The
that's it.
ground is a negative angle relative to the camera. The guy is a positive angle relative to the camera. If we can see the negative angle, why can't we see the positive angle?
So explain angles and the cameras. What's going on?
Your explanation is not coherent. The only answer is
It's
that
a
the image
question.
is being compressed, Coffee. I was talking to Coffee.
Bro, there's not that much compression in the world, bro. Like I'm telling you, it breaks wave
It's
symmetry.
being
I
demonstrated to
don't know,
you in
bro.
the
Like
video.
unless the shape of apertures for lenses don't changed in the last 100 years,
It's being
and we just
demonstrated in the
started
video.
using square apertures, bro.
Okay,
It's
why do
just
train tracks? Hey, why do train tracks converge? Why do train tracks appear to converge then? It's the same thing. Instead of being top to bottom, it's just left to right. It's the same thing. You can flip the camera on its side and it'll be top to bottom. What now? Why do train tracks converge, Coffee? Hello, we know that the train tracks are parallel in real physical space. Why do they converge in the camera? If you can't explain train tracks converging, you shouldn't be a part of this conversation.
bro, I'm not going on with the conversation, bro. Just go on with the little video. It's
Why do train?
impossible.
Why do train?
Oh, come
Like
on, coffee. Did you get cooked?
this doesn't support your argument, my
Nah,
Why
y'all
do
brother.
might
train
as well
tracks
change the
converge?
subject. Y'all might as well. Didn't y'all say
No, it's
y'all
the
don't want
same
to waste
subject. Why
time
do train
talking
tracks
about dumb
converge?
shit?
I'm
This
eating a
is
cookie
dumb.
right now. It's good cookie.
Hey, why do train tracks converge, Coffee?
But now
Been a
you're
long
starting to
time
sound
since
like
I seen
John, my
coffee
brother,
get cooked.
repeating the same thing over and
But
over
you
again.
can't answer the
Next
question.
topic.
It's the same thing. It's the same principle applying to this guy on the football field.
Bro, it's not. It's just not.
Was this
Oh,
experience? We don't know the camera settings. We don't know what type of lens. If I
it
use a
doesn't matter what
wide
kind of
lens
camera you
versus a
have. Train tracks will
it,
converge.
I'm not talking about the train tracks, dude. We're talking about the whole
Okay.
walking away from the camera thing, this and that and third.
Yeah,
But next
but it's the same
topic, I'm
thing.
over it.
It's being compressed, just like the train tracks are, into the horizon, towards the center of the frame.
One of my favorite shots. Next topic.
So if you can't explain how train
And,
tracks
and, you're,
converge,
and you're using that to explain my PTR to deem it's possible.
I'm using it to discuss why this guy's disappearing across the football field.
You
Are
using
we not?
a shot of
It's a
train
matter of
tracks, comparing it to somebody walking away.
it's
Oh,
perspective effects.
this conversation is getting
It's all
hilarious by the
perspective
minute.
effects. Coffee.
Right, but how does that relate to my PTR?
We're not. I don't know what your PTR is. We're not talking about that. We're talking about the
Look at my
football field.
PTR, my brother.
So curvature is a poor
Trust
person's
me.
way
To
of
me, hold on,
understanding
alligator. You hear me
angle
talking about
merging.
alligator? Have some damn respect. You hear me talking, my brother? I don't do that to you. Shit.
You're good. Oh, you're good, coffee. You're good.
But yeah, just look at my PTR. You'll see that they relate.
Yeah, you're talking about how the bottom of the boat's disappearing.
Yes, sir. Do you
Just
think
like
the
the bottom of the person is disappearing.
Yes, sir. Do you think the same explanation applies?
Yes.
Yeah.
Okay, then enough conversation here. You feel me? We could agree to disagree and just leave it there, my brother.
At least I can explain why train tracks converge and you can't.
I feel you, my brother.
Yeah. Well, it's been good. I'm not going to waste any more of my time here. You can lead a horse to water, but you can't make it drink. You guys have a good night.
Oh, yeah, it was nice to meet you guys. Better add you guys before you leave.
Yo.
Yeah,
Thanks for the
that about sums it up in there.
thanks for leading the horse.
We should
Dude, talking with
leave.
people of that level of mentality is not fun.
No, I know. Dude, like we went in there and I answered all those questions like immediately with math. I used the word parabolic to describe the 8 inches per mile squared. For 20 minutes, they lost their mind over trying to figure out what parabolic meant, and then I just
Dude,
checked out. I was like, oh
did
my
you
fucking lord.
did you see
Here's
how
the
he
clip
just
with the
went completely
football
silent
field.
when he realized that the explanation that he tried to use to
I think it's
explain that to me
the last
meant
clip.
that he had no
Yeah.
explanation for train tracks?
Yeah, that's coffee, dude. He always does that.
We'll just agree to disagree, bro.
Yeah. Let me just
It's
respectfully
the
disengage
Rumble
so I
link.
can never lose, please. Can you allow me that? Thanks.
At least I can explain why train track converge and you can't. I feel you, my brother. Looks like Alan's still in there.
Yeah, I am too. Well,
You guys have fun with that.
no, I'm done. I'm trying to end it so I can go to bed. Dude, that was a long time to end up with no conclusion. When you guys think that was crazy. That's what we call an endless dog shit.
Oh, that was crazy.
We started out with the premise that it's indistinguishable for both models on the surface, and then we
Oh,
spent an hour concluding
but
that
he's
with that
back.
premise.
Hey, you want to be entertained? He's working on a theory about this. Hey, CM, do you feel comfortable enough to go through your position 1 and position 2 with Shane? I know you
Yeah,
can hear me. Can you hear me?
yeah. What's called that these things are indistinguishable on a flat Earth and a globe Earth is completely false. There's a lot of ways to distinguish it. Uh, the bottom up obstruction doesn't happen in not the way we see it in like the PTRs of iron and coffee. Uh, I've talked to Jamal about this. Yes, he's still hanging on to Riley's criteria. We're telling him, imagine you're in an infinite hallway, just like a infinitely long hallway, and you roll a bowling ball or some shit. You roll a bowling ball straight down the middle, and just let it get further and further and further. There is no the whole, and you put a camera on the ground. There's no point where from the view of the camera on the ground, this bowling ball is gonna look like half a fucking bowling ball, and like the other half is just melted into the ground. That's never gonna happen. Uh, the only time it'll quote start merging with the ground is when the whole ball is gonna get so far as just shrinking to a point, literally shrinking to a point. When it starts shrinking to a point, getting at like your, your level, your distance, your perspective, that when it's like a point, yeah, at the point is also going to kind of merge into the ground. And and then even then, if you have zoom, if you can zoom in, you can just bring that bowling ball right back, the whole bowling ball. You're never gonna, maybe again millimeters or something on the bottom will be a little bit merged with the floor, but you can just zoom that shit out of existence. This you can do on an infinitely flat long hallway. uh this is not what happens. This is not the bottom up obstruction that happens of ships going off into the horizon. No matter the amount of zoom, you cannot bring them back.
All
Once they
right.
get far enough, you cannot bring them back.
All right, but like, so let's go back to the hallway, and let's say that if it's an optical effect, and we say it's a function of observer height, for an observer in a hallway with infinite vision, then the top and the bottom would compress equally, right? The top and the bottom would merge together
Correct.
equally based on the, okay, so that's how perspective works. We agree. Now, if we take that observer in that middle of the hallway, we move them to the lower limit, say close to the bottom, then that angular compression is now unequal. And now the top and the bottom will not compress equally. So the bottom will compress faster at a steeper rate. That will indicate visual bottom-up obstruction from the bottom. Now we can show this is an optical effect because we can.
Wait. You actually have
Hold
it
on.
backwards.
Hold on.
Sorry. When the camera is
Hold
on the
on.
floor,
Hold on,
you're
bro.
not gonna. You're gonna have.
Hold on. We can invert it. We can go to the top, and now we can do top-down obstruction. We can invert this. We can prove it's an optical phenomenon by manipulating observer height, putting a camera in the top limit, and watching the top of an object recede, disappear first with distance at the same rate. Now, the same thing would also happen when you approach a tall building and you look at the top floor. The angular compression would accrue top down instead. So now you've replicated the effect top down and bottom up. So now we're saying it's a bottom up obstruction. It's an optical effect, and we can prove it by mimicking and inverting it to show top down.
You're not talking about anything beyond perspective. Like even again with the building looking up. Yes, the windows will start getting closer and closer because of perspective. Like Linnell has a PTR of this thing of like a infinitely long fence with like spokes or whatever in the fence. And yeah, as they go off into your point of your vanishing point, the little spokes or the little fence posts start getting closer and closer and closer. This is not them disappearing bottom up. They disappear equally bottom up and top down as it goes off to the vanishing point. As they go away to just like a point, the vanishing point. You're not talking about anything beyond perspective, bro.
We started with that. You
And
repeated the same thing, right? In the hallway in the middle, then it's top and bottom would decrease at the same rate equally. Top and bottom would decrease equally, only if the observer is right in the middle.
yeah, I know. Well, I wish Jamal was here to hear you say that, because Jamal thinks that no, because of Raleigh's criteria, the bowling ball is gonna turn into half a bowling ball at some point. At some point, you're only gonna see, like literally, a bowling ball cut in half. The other half is gonna be like melted into the ground.
No,
That's what you're gonna see.
I'm pretty sure that no one says that's because of Rayleigh's criterion. That because of the angular resolution limit of the human eye, then
Oh my
things
God,
do become
Jamal will die on this
unresolvable.
hill.
Right? So again, if the observer is directly in the middle of that hallway and you have infinite vision, laws of perspective say the top and the bottom would disappear equally. It would lose information from the top and the bottom equally. You wouldn't have bottom of obstruction, you would have perspective vanishing until it approached the dot of nothing. However, if you change that observer height to anywhere not in the precise middle, you have a different effect. You don't have equal angles compressing equally. You have unequal angles compressing unequally, meaning the top or the bottom will increase faster or slower depending on if you move the observer up or down. That's the basic argument for perspective. So the closer you are to the bottom, the steeper the rate is for the bottom to obstruct faster than the top, the more bottom of
I
obstruction
think
that
you
you're
have it
getting.
backwards. You put if you're rolling a bowling ball, you put the camera at the like at the center of the bowling ball, you're gonna see it forever just disappear to a point. If you're standing, like if you put the camera like at your eye level standing up, then maybe because you're looking at the bowling ball from top down, you might see a little bit of merging on the bottom. But like again, such a tiny amount, it's gonna be unnoticeable, and you're gonna see the bowling ball is gonna again radially compress almost to a point way before you actually see it get cut off. Any substantial amount gets cut off from it. It's gonna again compress uniformly as it just gets further and further and further. You don't see this again, and then the whole point is you can always bring it back into view just zooming in. The point is you can't bring things back into view when they're over the horizon, like over the literal curve, because here there's curvature, and I mean you can bring it back a little bit because of light refraction, but there will be a limit. You won't be able to infinitely bring it back.
It's just the resolution limit, man. It's not that it's into over the horizon. It's that it's disappeared
Oh, the
into the
resolution limit.
horizon. So, like when you take out a camera, when you lose something into the horizon for your eye, and you take out like a P1000 or
Dude,
whatever
no,
camera
no.
you guys do, you're increasing your resolvable limit by increasing the angular resolution, so you see
Correct.
more.
Exactly.
You're not seeing further. You're just making what was undistinguishable visible. That's all the angular resolution limit does. So that's all. That's all we're talking about.
Exactly.
That's what
Well, the
zooming
point
in
is,
brings back.
so you think you can bring it back forever? I mean, like
No, you can't
it could
see
just.
forever. That's crazy. That's a crazy argument.
I mean, no. On a flat plane, you should be able to bring it back almost forever.
No,
Just,
that's retarded.
of course, dude. You get a
he
better
but
camera.
he already
Eventually,
talked
you get
about
a
the
telescope.
particulates.
You could pull
What
the
was the
Hubble
particulates
telescope out and bring it back,
thing
bro.
again?
You would be able to bring it back. Pull out the Hubble telescope.
But there's also infrared. I've seen like different infrared pictures where you can see farther.
Bro, you got iron up in here, bro. You got listen, bro. You got these
Kaz, if I bring you up here, you gotta behave yourself.
when do I not bro, what the fuck am I, a kid, bro?
No, 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 no. If I brought you up here, you gotta behave yourself.
Don't I always?
Yeah, yeah, yeah. I ain't seen you not.
Yeah, but you got iron here, you got why you got these little you got Teddy, man. I'm glad y'all got the stage now, bro. Cause these
You
niggas
know Teddy?
man, I was over here cooking them like earlier today or yesterday. I forgot when it
Oh,
was, bro.
nice. I ain't seen it yet.
I was cooking them, man. They got mad. You came to the room, I think you were like, Cass. They had me on the in the goo at that point, though. You know what I'm saying? But
Yo,
oh,
Shane. So you know Jamal?
cooking their ass.
Yeah,
Shane, you know Jamal, right?
yeah.
Dude went
Hey,
quiet.
Who's
Oh
the
yeah,
hell is
yeah, yeah.
Jamal?
Yep.
Jamal Cena.
He's the cult leader from this room. What's it called? Ask Jamal about this. I gave him this example of rolling a bowling ball down an infinite hallway. Ask him that, and ask
yeah,
him his
Jamal should be here.
Raleigh's
He created
criteria.
this really cool
What
paper that you
happens?
guys would like to see, Shane.
It keeps going forever.
Well, Jamal
No, it
used
shrinks
Claude
to a point. You never see
to
half a bowling ball.
jailbreak AI, and you could just put this framework into AI, and it'll just fix
All right,
itself. It'll
alligator,
just
shut the
snap
fuck up,
out of
bro.
its
Please, please, hold
hallucinations
on. I'm so happy
through some
Shane actually
scientific
agrees.
layering method. Jamal
Wait,
should be here.
alligator,
Let's all ping
alligator,
Jamal at
please,
once and
please,
see if
please,
he comes
please,
shows
please.
up.
No, just please. See what Shane agreed to in 1 second. I didn't even have to tell him to. He said the bowling ball should be disappearing to a point radially, like
If
just
if
the rate compression should be radial and uniform as it gets further and further. What he admitted on his own, this is what I was gonna get to. This is the main point I was gonna make. It was gonna disappear radially, compress radially, and come and just vanish to a point. That was again. That's what I was gonna get to. Jamal can't even understand that. This guy
that's
understood it on his own. Said it before I could say it.
I said
Jamal's gonna ask him. Jamal's gonna tell you no. It's gonna get. He's gonna make up some random numbers. What's his like 3.5 miles away? Because the bottom of the bowling ball is closer to the floor than the angle between the bottom of the bowling ball and the floor is going to make it merge. So eventually the bowling ball is going to start becoming squished like bottom up obstruction. Like we're only going to see the top of the bowling ball. It's going to be
yeah.
rolling, but it's a
You
semi
you
hemisphere
you
rolling and
you
shit.
you butchered what we said here, but I said if you're in the middle of the hallway
Yeah, yeah,
precisely,
in the middle.
and if you could see forever, then it would disappear into a point. Those are the two
Yeah,
qualifiers that
so
I
like that's
agreed
the
Yeah,
to.
yeah.
thing.
Facts.
Very
See,
important to say that that's what I agreed to instead of being like,
no,
see,
no, no. Regardless, you never see half a bowling ball.
it's
And
not
yes, I'm
regardless
talking
because I
about.
proceeded to say exactly that you would see half the bowling ball because the bottom up obstruction, if you lower the
No,
observer
no,
height
no.
lower
Again,
to
you
the
said
lower
no.
limit,
Put the
then you
bowling ball
would.
level.
Yeah.
Put the camera level with the bowling ball. Dead in the center of the bowling ball. If the bowling ball is 10 inches, put it 5 inches, 10 inches tall. Put it 5 inches from the ground, the center of the camera. So it's like level straight onto the bowling ball. You're never gonna see half a bowling ball
Nobody
ever.
sees forever. That's retarded. So it's a
No, no, no.
hypothetical
You
example.
don't
Like
see
that's
forever. You're gonna see
that's
again
why
to your
it doesn't.
resolution limit. You're gonna see it shrink to
What
a
you're
point,
saying to expect in
bro.
reality is ridiculous
No,
because
I'm not.
we're
You're gonna see it
using an
shrink to a
example
point.
of infinity. I was saying I can see
Shane,
forever,
stop it.
therefore it should look like
You're not
this.
gonna see
Yeah, yeah.
No
forever. You're
one
gonna
sees
see it
forever.
at a
The first
certain
time that I
distance.
said this,
God damn it! Shut the fuck up. At a certain distance, you're gonna see it shrink to a fucking point where you can't resolve it anymore. That's my point.
All right,
But as
bro.
it
All
shrinks
right.
to a point,
It's shrinking again.
Yeah, I couldn't do any more of that guy. Just repeating. All right, I'm out. Let's close out the stream. Alan's in there still. He'll be fine. I'll figure it out.